run in right will be number 5. I make a copy of this block and name it run in left. I put run in left here. I check my sprite sheet and the row for this animation is 7. When we release left while in this state, we will switch player into stand in left state. And when we press right, we will switch into run in right. I also copy this line of code from here, and when we press down from run in left state, we will go into sit in left state. Duplicate this and turn it into run in right state. If we press left arrow key while in run in right state, we will switch into run in left. If we release right key, we will go into stand in right, and pressing down arrow key will make player sit to the right. Not every game needs to have left and right version of each state. Also, there are other ways to write code when you have a set of states that each has left and right version, or maybe each state has a version with weapon ready and weapon hidden, for example. Again, I'm doing it like this for simplicity and to demonstrate the main idea of my version of state management pattern. So we defined behavior for player while in running states. Now we need a way to actually enter these states. We can enter running from standing state, for example. While standing left, if we press right, we set state to run in right. Here inside run in right state, we see that when we release right key, it will switch back to stand in right state. So we are only running as long as the key is being pressed down. If we press left while in stand in state, we will start running to the left. I get this error because I refreshed my project before I finished adding new state on player class. Don't worry about that. While in stand in right state, if we press left, we will start running left. If we press right, we will start running right. So here we are exporting two new state classes we just wrote. Here we are assigning them values 4 and 5. These numbers need to correspond to indexes to order in which we add these states inside this .states array here. First, I import them on line 1 as usual, and then I add instance of run in left class as index 4 in this array, and run in right will be the 5th item in this array, counting from 0. I save changes to all my files. Run in right animation is row 6 in our sprite sheet. Perfect. It works and swaps between running and standing states correctly. We also want player to actually move when in running state, so let's give it this .speed property and set it to 0. Then I create max speed property and I set it to 10 pixels per frame, for example. When we enter running state, we set player speed to player max speed, and in running left, we set player to minus player max speed because moving left is in the negative direction on horizontal x-axis. Inside update method on player class, I will be adding player speed from line 16 to horizontal position from line 12. Problem now is that player will just move off screen because even when we switch away from running state, nothing is setting player speed back to 0. So when we enter stand in left state, we set player speed back to 0. We do the same thing inside enter method on stand in right, sit in left and sit in right state. Perfect. Player now stops moving when we enter stand in or sit in state. I will also introduce horizontal boundaries so users can't move player outside the canvas. If horizontal position of player is less or equal to 0, I set the position to 0. Else if the position is more or equal to game width minus player width, meaning player's right edge is touching right edge of canvas, I will also not allow it to move past that point. This is going so well. We applied state management to our player and we have granular control over its behavior separated for each state. We can do so many things with this. Common thing you will see in games is jumping. Again, there is a new small trick we have to use here. If you never coded jumping in a 2D side-scroller game, we will learn how to do it properly right now, and we will make it look really good by switching player to a separate falling animation after it reached peak height of its jump. Let me show you that swapping between states doesn't always have to happen on user input. We can also tie state swapping to other game events. In this case, we will swap player from jumping into falling state after it reached maximum height of its jump. We are creating new states. As usual, I will first add them up here to our states object, which we are using to pair readable state names with numbers that represent each state. I copy already existing state class and I turn it into jump in left class. I check my sprite sheet to see which row has jump in left animation frames. I delete player speed, I think, because I want the speed to be inherited whether we enter jump from stand-in or run-in state. We will see about that. I delete all these inputs for now. I copy this block and turn it into jump in right class. Frame Y for jump in right is row with index of 2. I go up to stand in left state, and when input is pressed, we switch player to jump in left. Inside stand in right state, when we press up arrow key, we set state to jump in right. I'm exporting these new state classes, so in player.js I can import them. And I instantiate them inside player states array. I'm getting an error. It's because up here in my enum I skipped some values. Let's assign my new states to the correct values. Now we correctly enter jumping state. When I'm in that state, it doesn't matter what I press, we are locked in that state, because inside handle input method I didn't give it any way to switch off to a different state. First, when we enter jumping state, let's push player upwards on minus direction on vertical y-axis. When we enter, I say this.velocity y minus equals 20. I do the same for jump in right state. In player.js inside update method, we will deal with vertical movement here. I give player vy, velocity y property, and I give it property I call, for example, weight. I could have also called it gravity or something. I will use velocity y to pull player upwards and weight to pull player down. As the ratio between these two values changes during the jump, it will create a nice jump-in curve. For every frame, we will add this.velocity y from line 14 to player's vertical y position from line 13. Right now, velocity y is 0, so even when we are adding it, there will be no vertical movement. If player is not standing on the ground, so if player y is less than this.gameHeight minus player height, gradually add value of player weight to velocity y. Else, meaning player is standing on the ground, set velocity y back to 0. Give me a second to figure this out to make sure I'm doing it correctly. In state.js here, I actually want to access a velocity y property on player object, so this.player vy minus equals 20. I get small jump and it stops moving again. Oh yeah, this is a typo. This needs to be game height. Now it's working. We have multiple places in our code where we need to check if player is standing on the ground or if it's currently in the air. This is a good time to create a small utility method on our player. I will call it onGround, and its job is to check if player is standing on the ground. I will just make it return true or false directly like this, based on how this expression evaluates. If player's y-coordinate, which is the top edge of player image rectangle, if it's more or equal than game height, so this point, minus player height, so if this point is more or equal than this point, we know player is standing on the ground, so this method will return true, else it will return false. Now I can just call this method whenever I need to do this check, and it will also make the checks more readable. Here on line 32 I'm checking if player is not on ground, so I say if on ground is false. Actually, if this.onGround is false, now it's working. I want player to be able to switch sides while jumping. So in jump in left state, if we press right arrow key, we set state to jump in right. In jump in right state, if we press left arrow key, we set state to jump in left. Player is flying off screen really far. Let's change this to minus equals 10. That's a very small jump, but you will notice a bug here. If I swap between jump in left and jump in right quickly, each time we enter these states, we are running their enter method, so each time we push player further and further up. I want the player to only be able to propel itself further up if it's standing on the ground, so in enter method on both jump in states, I will first check if player.onGround is true before we push it upwards. If it's already in the air, this will be false and player will receive no vertical push. I change these values to minus equals 40. I just make sure I spell onGround correctly. Perfect, we are able to turn to sides while jumping. I will actually give it some horizontal speed as well. When we enter jump in left, set player's horizontal speed to half of player's max speed. And the same for jump in right. In jumping left, it actually has to be negative number, since we want to move in minus direction on horizontal x-axis. That works, awesome. I can switch between jumping left and jumping right states, but otherwise I'm locked in jumping. I didn't give it any way to get back to running or standing state. Inside jumping left, I check if player on ground is true, and when player gets back on the ground, we set its state to standing left. In jumping right again, we check if player is back on ground, and we set it to standing right. We are running, standing, sitting and jumping. Well done if you followed this far. Let's polish this and make it look even better. Jumping works this way. We are always adding velocity y to player's vertical position here on line 31. Most of the time, that velocity y is 0, so there is no vertical movement. When we enter jumping state, we set velocity y to minus 40, which will push player upwards, in minus direction on vertical y-axis. When that happens, player is no longer standing on the ground, so this if statement triggers, and we start increasing velocity from line 14 by player weight from line 15. This happens for every frame step by step, so actually velocity y goes from minus 40 to 0, making player move up slower and slower. When it's 0, player will stop moving. At that point, we are still not on the ground, so this line of code keeps increasing and it moves velocity y from negative to positive numbers, which will make player reach peak of its jump and it will start falling back down. When we touch the ground, this else statement triggers, velocity y is set back to 0 and vertical movement will stop. Understanding how velocity y goes from minus 40 to 0 and then into positive numbers gives us ability to tie player state change to it. I can tell that player is at its peak of its jump because its velocity y switched from negative to positive values. I will just add a quick check here to make sure player doesn't fall through the floor. It shouldn't happen, but this is kind of my insurance. If player y is more than game height minus player height, set player y to game height minus player height. This line will make it impossible for a player to move below ground level under any circumstances. I don't think this check is needed. Even when I increase player weight to 10, we still don't fall through the floor. Maybe you can just comment it out, it's up to you. It's just a check to be secure. I created falling states. Falling left is 8 and falling right is 9. I copy one of my state classes and I turn it into falling left. Enter method will just set frame y to 5. Inside handle input method, while in falling left, if we press right arrow key, we want to turn, so we will switch to falling right. I also want to keep this check. When we fall all the way to the ground, we will switch player to standing left state. I copy this and turn it into falling right class. Frame y here will be 4, and when we press left, we set state to falling left. I import these classes in player.js and I instantiate them inside player states array. So how do we enter falling state? As we said, when we enter, jump velocity y is set to minus 40 and we start adding player weight to it. So it goes all the way to 0 and into positive numbers. I know at the point velocity y reaches 0, we are at the peak of jump, and as it goes into positive numbers, player is falling back down. Bear with me a second here, please. So inside the jumping left state, if velocity y on player object is more than 0, we set player state to falling left. Inside the jumping right state, if velocity y is more than 0, we set state to jumping right. So this is one example of how you can switch states based on other conditions. State changes don't always have to be triggered by user pressing keys on keyboard. This works really well. We created standing, sitting, running, jumping and falling states. We are just drawing the first frame in each sprite row. Let's actually animate the frames horizontally. We have frame X property for horizontal navigation within our sprite sheet. For every animation frame, I check if frame X is less than max frame and I increase frame X by 1. I set frame X back to 0. Some rows have different maximum number of frames, but that's easy to deal with. Initially, I set max frame to 5. We are counting from 0. You can see that sitting animation has less frames, so it's blinking since we are animating empty frames. We will start with standing animation, so the initial max frame is 6. Every time we enter a new state, we set max frame to a different value. When we enter stand and left, we set max frame to 6. Probably I should be setting max frame before I set frame wide, because in some cases if I switch row at first, we can get blinking before the right max frame is applied. Or maybe I could also set frame X to 0 every time we enter a new state. I'm not gonna go deep into this today. I made other episodes about sprite animation. This is just a quick solution. Running left and running right will set max frame to 8. Jumping and falling have max frame 6. Awesome, we are correctly animating all our rows. If you want to make a player move faster, you can change max speed property here on line 20. This value affects horizontal movement. The sprites are animating very fast. Maybe I want to slow them down a bit, without changing FPS of the entire game. How do I set FPS for how often we switch between horizontal frames in sprite sheet, while still keeping everything else running at maximum 60 FPS? As always, we can use timestamps and delta time. Last time will be the value of timestamp from the previous loop. Animate takes this auto-generated timestamp argument, which was produced and automatically passed to it by request animation frame from line 23. Delta time is a number of milliseconds that passed between the last animation loop and this animation loop. It's the difference between timestamps from each loop. So delta time equals the timestamp from this loop minus timestamp from the previous loop. When we have that calculation, I set last time to the current timestamp so that it can be used for the next loop. I also have to pass animate the initial timestamp just for the first loop, because request animation frame auto-generates it from the second loop onwards. So now we have delta time. We know how many milliseconds it takes for our computer to serve the next animation frame. It depends on power of our machine, how much animation and calculations our game is doing per each frame, as well as on refresh rate of screen we are using. This number can be different for every computer, but we can use it to unify how our game runs across different machines. Today I will use it to control how often we serve the next horizontal frame in doc sprite sheet. I pass delta time to player draw method here, and in player.js I make sure draw method expects that argument. Timing things with delta time needs 3 helper variables. One variable to set FPS, frames per second, one timer variable that will accumulate delta time until it reaches a certain value, and one variable that defines that value we want to reach. I call that value frame interval, and it will be 1000 milliseconds divided by frames per second, which will give me number of milliseconds I want each frame to be displayed on the screen before we switch to the next one. So if frame timer from line 22 is more than frame interval from line 23, only then switch frame x variable. At the same time, set frame timer back to 0 so that it can count again. Else, just increase frame timer by delta time and wait until it accumulates enough milliseconds. It's not working. I see, here in animation loop, I need to correctly assign last time to the new timestamp value after we used it to calculate delta time, so that it can be used to calculate delta time in the next loop. If I change FPS, it affects how fast we serve horizontal sprites, while still allowing player to move around at maximum 60 frames per second, or whatever your request animation frame can handle on your computer. If I give it FPS that's higher than my screen's refresh rate, request animation frame will automatically cap it, so it won't animate faster past a certain value. That maximum value of frames per second is limited by your screen's refresh rate.
Making games with JavaScript is one of my favorite ways to practice coding. Today, we will build a 2D game and we will animate everything to bring it to life. I want to show you how to make keyboard controls feel quick and responsive. We will apply animated sprite sheets and parallax backgrounds. We will learn how to give our game different skins. We will explore a new technique to make particle effects, and we will challenge our players by giving different enemy types different behaviors. On my community page, I asked you to choose between 3 superpowers, and you chose the Fireball Tackle. So let me show you how to turn into a flaming ball of plasma and vaporize enemies to earn points. Come join me and learn how to create your own 2D adventures with HTML, CSS and plain vanilla JavaScript. No frameworks and no libraries. Click the like if you want more games. keep the code organized and easy to navigate in, I will split JavaScript into multiple files, so-called modules, and I will export and import them around the codebase as needed. To enable this functionality, we have to run our code in some kind of dev environment. They need to be run through some kind of server. You might already have a preferred way to run a local server. You can go ahead and do that. For the rest of us, the easiest way to create a simple local server is to use VS Code editor, which has a built-in one. When you open your VS Code, check if you have this notification area down here that says Go Live. If you can't see it, you can just come here to extensions and search for live server. It's this one. Mine is already installed. You can just click install here. When you install it, close your VS Code and reopen it, and you will see Go Live down here. One last thing to do, we have to point VS Code to the correct folder with the files we want to run through this live server. We do it by going to File, Open Folder, and in there you navigate to the folder you will work with today on your local computer and click Open. Now, when I create new files, they will be automatically created in that folder. So I create index.html, style CSS, and main.js. In index.html, I create a basic blank web page markup. In VS Code, you can just press exclamation mark and tab key and it will create it for you. Let's give it some title and a link style CSS file like this. I create a canvas element with an ID of canvas1. Down here, I link my JavaScript using a script tag. I give it type attribute and set it to module to specify that this file will be a JavaScript module. It will be my top level module and we will be importing other JavaScript modules inside. I click this Go Live button and the Live Server plugin will automatically open my default browser and it will run our project in it. It will also automatically reload the browser window whenever we save any of the project files. You don't have to use VS Code and Live Server plugin. If you know how to create your own local server in a different way, feel free to do that. So now I can see my live server is running on port 5501. It will reload browser window whenever I save any project file. I usually use Ctrl+S keyboard shortcut to save. Sometimes you have to manually reload the browser page for the first time and then it will start doing it automatically. In style CSS, I reset margin and padding to 0 on all elements and I set box size into border box. This is so-called global reset and we do it to make sure our page looks the same across different browsers. Canvas 1 will have border 5 pixels solid black and I center it in the middle of the page, so the usual 4 lines of CSS, position absolute, top 50%, left 50%, transform translate -50%, -50%. I will provide you with game art assets you can use to code along with me, and at the end in the experiment sections I will show you how to apply different skins to your game so that you can make it unique based on your own creative preferences. Check out this website for more beautiful art assets that are already compatible with today's project. Today we will be using images for player, backgrounds, enemies and other things. The easiest way to make sure our code runs only after all art assets are loaded is by placing the images inside index.html, which we will do in a minute, and we will put all JavaScript inside a callback function on event listener for window load event. That way, JavaScript waits for all dependent resources such as style sheets and images to be fully loaded and available before it runs. When the page is fully loaded, we will point JavaScript towards our canvas element using its ID. I create an instance of built-in 2D drawing API using getContext method and I save it as CTX, shortcut for context. Canvas width will be, for example, 500 pixels and height 500 pixels as well. You can make your project wider, but keep the height at 500 pixels for now because I optimized the background images for that size. We can make canvas scale up and down to make sure it's always fully visible. If I set width to 1500 pixels, we can only see the middle. It's cut off on left and right. I can give it max width 100% and it will make it scale down until it's fully visible, whenever the width of the page is less than the width of the canvas element. I can also give it max height 100% in case that the restricting factor is page height. Now we can always see the entire canvas regardless of its width and height. I set it back to 500 for now. The main brain of our project will be this game class. All logic in our project will somehow go through it. It will expect width and height as arguments, and inside we convert these to class properties like this. It will have update method that will run for every animation frame and trigger all calculations that need to happen, and draw method will draw our images, score and so on. Right now we don't have anything to update or draw yet. I create a new JavaScript file called player.js. If you are a beginner, it will be easier for you if you follow my code exactly and use the sprites and images I provide you. And only once you have a working project, then you can modify it and add your own art assets and game features if that's what you want to do. Inside player.js, I create a class called player. Its job will be to draw and update our superdog character. Constructor will take the entire game object as an argument. Through it, we will have access to some things we will need, such as width and height of the game area and so on. JavaScript objects are so-called reference data types, which means when I pass the entire game object to other classes like this, I'm not creating a copy of the game object, I'm just pointing to it. So now it's time to bring player image to the project. It was provided by this talented artist and you can download it for free in the video description and use it for learning purposes to follow along with this class. Check out their website for more game art assets if you want to make your projects unique. So we have some images and sometimes it can take a while, maybe even a couple of seconds for the images and audio files to load. In JavaScript, if you try to use an image that hasn't yet been fully loaded, you will get an error. We need to make sure our images are loaded and available before we draw them. One way to do that, and the simplest way to do that, is to actually include those images on our web page. I simply create an image element, and as a source, I point it towards the image file. I have a folder called assets in the same place where my index.html file is, and in there, the image I want is called player.png. I give it ID player like this. I will draw that image on canvas with JavaScript, so I don't really want to display it on the web page like this. In style CSS, I target it using its ID and I set its display to none. It's a good practice to make your images the exact size you will use in your projects. We can scale it down with JavaScript, but for maximum performance it's better to size your images in Photoshop or some other graphics editor. I already did that with the images I gave you today and I sized each frame to the same size we will display in game. The width of each single frame in the sprite sheet will be 100 pixels and height will be 91.3 pixels. If you are using your own sprite sheets, you can get the width of a single frame by taking the width of the entire sprite sheet and dividing it by the number of horizontal frames. And height is the height of the entire sprite sheet divided by the number of vertical frames, the number of rows. Player will also need to be positioned somewhere on canvas, so it will need X and Y position. It will have update method that will move it around based on user input and it will cycle through the sprite frames. And the draw method will take those values and it will draw currently active frame at the current coordinates. It will need context as an argument to specify which canvas element we want to draw on. Let's start by calling fill rectangle first and we draw it at coordinates this.x, this.y, and we also specify its width and height. If I want to use this JavaScript class in a different module, in a different file, I need to export it. I can just say export like this. Each file can have unlimited amount of exports. Or I can say export default. Each file, each module can have only one default export. In main.js, I import player class by going up top and saying import player in brackets like this from ./player.js in quotes. Class constructor on JavaScript class is a special type of method. It gets automatically executed when we call this class using the new keyword. It will create one new instance of this class, and as a side effect, all the code inside the constructor will run. We can take advantage of that by putting in any code we want to run at that point. When I create an instance of game class, I also want to automatically create an instance of player class. Since I'm importing player class on line 1, I can instantiate it here. This.player property on game class will be new player like this. Inside player.js on line 2, I can see that player class expects game as an argument. So here, since we are inside that game class, I will pass it this. Inside game class, this keyword means this game object. Now that we have access to the player object from within game class, here inside draw method, I can take this.player from line 13 and I call its draw method. We declare that draw method here on line 12 inside player.js, and I can see it expects context as an argument. My main public method will be this draw on game class. It will get context passed from the outside in a minute, and we will just pass that reference along to player draw like this. Our game class is complete. Let's create an instance of it. I need to pass it width and height, so I pass it canvas width from line 6 and canvas height from line 7. So now we created an instance of game class which triggered class constructor, and that automatically triggers class constructor on imported player class and also creates our player. Make sure you save changes to both player.js and main.js file every time you make any change. If you have any unsaved changes in player.js at this point, you will not get the same result as me. I console log a game and I can see it has height, width, and it contains player object as we defined in the constructor. Perfect. We will also need animation loop because I want the game to update and draw over and over 60 times per second. I create a custom function I call, for example, animate. Inside I call game.draw from line 18 and as context I pass it ctx from line 5. Then I call request animation frame and I pass it animate to create animation loop. When I call it, we are drawing this black rectangle representing player object. Nice. This code inside the draw method on player class will determine what the player looks like. I can make it red, for example. I can move it around by changing its coordinates. If I want to align the player on the bottom of the game area, player object needs to be aware of game height. I have width and height of the game area here as properties on game object, and I'm passing a reference to the entire game object to the player here. Inside player.js, I convert that reference to a class property called this.game, and I can extract width and height of the game from that. So to position the player on the bottom of game area, I set its vertical y coordinate to this.game.height minus this.height, height of the player. I don't really want the player to look as a red rectangle. We have a special sprite sheet with our super dog to use here. We are about to learn how to use built-in draw image method to animate a game character from a sprite sheet. If you want to go deeper on sprite animation, the very first episode in the series linked below will explain it in a beginner-friendly way. This is an advanced video. If you feel it's too challenging for you at some point, don't worry. It will make more sense if you keep going and you can always watch a special episode describing each technique on a simpler project. So draw image is a special HTML canvas method we can use to draw and even to animate an image. It's simple. I have my player sprite sheet here in index.html and I gave it an ID of player. I create a property on player class called this.image and I point it towards that image element using getElementById. Now I can draw that image. Draw image method needs at least 3 arguments. Image we want to draw and x and y where to draw it. By the way, I'm not sure if you know, but I don't really have to use getElementById here. I give my image ID of player here, and JavaScript automatically creates references to all elements with IDs into the global namespace, using its ID as a variable name. So I can simply just use that ID as a variable name here, and it will still work. It's a bit strange, and for some reason nobody uses this feature, but it will work. I will go back to getElementById here, even though it's kinda redundant. DrawImage method can also accept optional 4th and 5th argument for width and height, and it will shrink or stretch the image to occupy these dimensions. Now it's just squeezing the entire sprite sheet into the small space. The longest version of DrawImage method takes 9 arguments, and that's the version we need. We pass it image we want to draw, source x, source y, source width and source height of the rectangle we want to crop out from the source image, in our case a single frame of the sprite sheet, and destination x, destination y, destination width and destination height will define where on destination canvas we want to draw that cropped out rectangle onto. At first, I just want to crop out the top left frame in my sprite sheet, so I crop from coordinates 0, 0, and the area will have a width of 100 pixels and height of 91.3 pixels. I'm cropping out exactly 1 frame. I don't need the red rectangle anymore. We are redrawing the same image over and over 60 times per second, but it looks static. Let's check if we are actually animating by putting some code inside player update method. For every animation frame, I want to increase player's horizontal x coordinate by 1 pixel. To actually run the code, I need to go to update method on game class and I take this.player from line 13 and I call update on it like this. Finally, I call game.update from inside animation loop and we have some motion. Congratulations, you are a JavaScript animation master. Okay, we can do a bit more with this if you want. The dog is leaving a black trail behind. That's old paint, we can just see all the previous frames. If you want to see only the current animation frame, we need to clear canvas each time we update and draw. I call built-in clear rectangle method, and I want to clear the entire canvas from coordinates 0, 0 to canvas width, canvas height. Now we can just see the current animation frame. I don't really want the player to move like this. Let's comment this out. I want the player to move left and right, jump, and to use superpowers based on keyboard inputs. I create a new JavaScript file, a new module, I call it input.js. Its job will be to capture and keep track of user input. Again, I will create a JavaScript class here. I will call it, for example, input handler. Inside its constructor, I create a property called this.keys, and I set it to an empty array at first. I will be adding keys that are pressed down into this array and removing the keys that are being released. That way we can always check if a specific key is pressed by checking if it's included in this array. As we said before, the code inside a class constructor is executed automatically whenever we create an instance of this class, so I will take advantage of that and I will apply keyDown event listener from here. Event listeners return an auto-generated event object, which contains all kinds of information about the event that just occurred. The property that holds the name of the key that was pressed is called key, so let's console log e.key. I export input handler up here. Inside main.js, I import my new input handler class, same as I did with player. I will create an instance of input handler class inside game class constructor. I will call this property this.input. This way, input handler class gets automatically instantiated when I create an instance of game class. It will create this.keys array from line 3, and it will also automatically apply this keyDown event listener. Now, when I press keys on my keyboard, I can see their values. I don't want to react to every key. We will ignore some and we will only respond to specific controls defined here. We will also make sure each key can be added to this.keys array only once, so when the user holds down a specific key, it will not be added 20 times, it will just be added once. Let me show you. I say if e.key, meaning the key that was just pressed, has key value of arrow down, and at the same time, this key that was pressed is not yet included in this.keys array, so this.keys index of e.key is equal to -1. You can also say is more than -1. In JavaScript, when element has index -1, it means it's not present in the array. Then I just do this.keys push e.key. So if the key that was pressed is arrow down, and if arrow down is not yet inside this.keys array, push arrow down into this.keys array. I can console log key that was pressed and this.keys array. You can see it will stay empty until I press arrow down. If I press it, it will be added to this.keys array once. I will also create an event listener for key up event. If e.key is arrow down, meaning if the key that was released is arrow down, I will use splice method to remove it from this.keys array. Splice method takes at least 2 arguments: index of the element we want to remove and how many elements to remove at that index. Let's test it. Actually, to test it properly, I want the console log after the if statement. Now, when I press arrow down, it gets added to this.keys array through the code inside keyDown event. When I release it, key up event removes it from the array. Perfect. I also want to listen for arrow up key, so I use OR operator. Be careful about brackets here. I have to wrap this block in brackets like this. If key that was pressed is arrow down or arrow up in brackets, and at the same time the key is not yet present in this.keys array, only then push it inside. I also need to make sure I remove that arrow up key on key up event. Again, pay attention to how I use brackets here. It's easy to make a mistake here and break your code. We will also listen for arrow left, so OR operator e.key is arrow left, and another OR operator, and I check for arrow right. I will check for one more key for now. I will use it for a special move and attack. And you can use Alt, Control, but be careful. Mac and Windows call Alt and Control keys differently. They might have a different value. Console log e.key and press them on your machine to check for that value. In this case, I will use Enter key, which should be more universal and compatible with both Mac and Windows systems. Let's add all these keys to key up event as well. And I have to make sure my syntax is correct. Now it should work. I click my canvas to select it, and when I start pressing arrows and enter, I can see they are correctly being added and removed from the array. You can see we are also keeping track of multiple key presses at the same time. Great. So now, this.keys property on input handler class always contains all currently active keys. I have an instance of that class here, saved as this.input. For every animation frame, I want to pass the current list of active inputs to player update method as an argument so that it can react to it. I will pass it this.input.keys, Inside player.js, I make sure the player expects that input value. I will call it, for example, input. It still refers to this.keys array we have on our input handler class. Inside update method on player class, I want to check if it includes specific values. I use built-in array includes method. I could also use index of method here, it would work the same. If input includes arrow right, increase horizontal x coordinate of the player by 1. Else, if it includes arrow left, decrease x by 1, making the player move left on the negative direction on horizontal x-axis. I actually need to say this.x to correctly refer to the property from line 6. The error I'm getting now is because I didn't save my changes to input.js or main.js files. With file structure like this, when we're using modules, we always have to make sure we save every file whenever we make any changes to it. Now when I press right arrow, player moves right. When I press the left arrow key, the player moves left. Let's refactor this. I give player a speed property and initially I set it to 0. I also give it max speed property, which will be its speed in pixels per frame when it's moving. So this section of code will handle horizontal movement for every frame. I will increase player's horizontal x position by its current speed. So right now the speed is 0, so the player is not moving. Down here I say if input includes arrow right, set this.speed to max speed. If it's arrow left, set speed to minus max speed. Now I can move left and right again, but I can't really stop. There is no condition when the speed returns back to 0. I can fix it by saying else this.speed is 0, meaning if input array doesn't include arrow right or arrow left, stop the horizontal movement. I also don't want the player to be able to move outside of the game area, so I need to introduce some boundaries. I say if this.x is less than 0, set this.x to 0. Now I can't move past the left edge. I also say if this.x is more than this.gameWidth minus the width of the player, set x to gameWidth minus player width. Now I can't move past the right edge of game area as well. Perfect. It's time to handle vertical movement, which will include jumping and also a special dive move where we crush enemies from above. I create a new class property called this.vy, velocity y, basically a vertical speed. Initially I set it to 0. For every animation frame, we will add the current vertical velocity, vy, to player's vertical y position. Currently vy is set to 0, so there will be no vertical movement at first. I will have to check in multiple places in my code whether the player is standing on solid ground or if it's currently in the air. To make our code more readable and to avoid code repetition, I will put that check into a small utility method. I will call it, for example, on ground, and I just want it to return true if the player is on ground or false if the player is in the air. I do that simply by saying return this.y is more or equal to height of the game minus the height of the player. Let's start by saying if input includes arrow up, set this.velocity y from line 8 to minus 20. I press up arrow key and the player just flies up off screen. Okay, that worked. I only want the player to be able to jump while it's standing on ground. I don't want it to jump higher and higher in the air when we are pressing up arrow repeatedly. I add one more check here to see if on ground from line 28 is true. I set velocity y to minus 2. Nice. If you want a nice jumping curve in a 2D game, we usually do it by making the power of the jump, in our case Vy property, work against the gravity or weight of the object. And while that object is in the air, we keep increasing its weight until it eventually is higher than its jump power, and it will make it slow down and start falling down. Let me show you exactly what I mean. This used to be a bit confusing for me, but it becomes easy when you use it a few times. I create a new property called this.weight, for example, and I set it to 1. So we have velocity y property on line 8, and when we press up arrow key, we set it to minus 10. This will be the power pulling the player upwards. At the same time, I want the weight of the player from line 9 to be pulling it down, and I want that pull to be stronger the longer the player is in the air, to get that smooth curve when we jump. I do that by saying whenever this.onGround is false, whenever the player is not standing on the ground, increase its velocity y by this.weight. Nice, we kinda jumped. I also need to make sure that when the player lands back on the ground, velocity y is reset back to 0 to stop all vertical movement. I say else this.velocity y is 0. For this to actually work as intended, I need to first run this line of code and then this one. And we are jumping. Velocity Y is constantly being added to player's vertical Y position. At first it's 0, so nothing is happening. When I press up arrow key, I give it a push in the negative direction on the vertical Y axis, so upwards. At that point, the player is currently not on the ground, so this line of code will start running, and velocity Y, which is currently set to -20, and which is moving the player 20 pixels up per animation frame, will start decreasing by this dot weight from line 9. So -20 plus 1 is -19, -18, -17, all the way to 0. When we reach velocity Y of 0, player is at the peak of its jump, but it's still not on the ground, so this line is still adding weight to velocity Y, making the player fall down faster and faster. When the player hits the ground, this else statement will set velocity Y back to 0 and the jump is finished. The ratio between weight and this minus value will determine the curve, height and speed of the jump. I will keep weight at 1 and I will adjust velocity Y to make the player jump all the way to the top of the game area. We have running and jumping. I would like to add more player states and properly animate them. We need a fireball attack, and when the player sits down, I want the game to stop scrolling. How do we organize and manage this functionality? By structuring our JavaScript code in so-called state design pattern. I will show you exactly how to do that in the next part. We are building a fast-paced animated side-scroller game with vanilla JavaScript and HTML canvas. In the first episode, we created the main game logic, animation loop and the player. Let's continue building our game. In this class, we will apply state design pattern to our player to make it switch between the states properly. We will learn how to control FPS, how to animate sprite sheets, and how to implement multi-layered seamless backgrounds with scrolling speed that reacts to player movement. Part 1 is linked in the video description. Let's go! I like writing my code like this for small simple games. As you can see, there are quite a lot of if-else statements in here already. I want to add some special moves. This single code block already does so many things, and we have just running and jumping. If we keep adding more and more in here, we can get to the stage where changing one line of code can break something else unexpectedly. For small games it's fine to have all logic in one place like this, but for this game we will go ahead and structure our code a little bit better. I will manage player states separately in its own file. I call it playerstates.js. At first, I will create a simple enum object that will pair values and names of each state. It will help with code readability. Rather than swapping to state2, I will swap to state.jumpin, which has a value of 2 behind it. It will be easier to see what our code is doing. This episode might be a bit challenging for beginners. We will be passing values around between JavaScript modules and classes, and I can imagine if you are a beginner, it might take some effort to keep track of which values are coming from where. I will guide you through all the steps and we will make our code easy to navigate in, but this is the finale of my vanilla JavaScript 2D game development series, so I expect you either already watched my beginner-friendly episode on state management linked in the description, or that you have already done some JavaScript coding before. I will explain everything today. No previous knowledge is needed, but it will be easier if you watch the beginner class first. It's up to you. Today's tutorial is mainly to show you how I put everything together to make a polished animated game that feels good to play. Check the video description for the full series. I create a class I call, for example, state. Each state will have its own class so that I can give each state a different enter method to set the player up when it enters that particular state, and handle method that will react to different user inputs depending on which state the player is in at that moment in time. For example, when the player is in the running state and I press arrow down, I want to switch to sitting state. But when the player is in jumping state and I press arrow down, I don't want the player to sit in the air. I want it to do a crushing dive attack from above. State design pattern is perfect for changing how the object behaves depending on its current state. I will show you exactly what I mean as we write the code. Constructor will take a single argument called, for example, state. It will be a simple line of text with the name of the state, such as sitting,
running, jumping, and so on. Inside, I converted that argument to a class property. I will use this value only so that I can console log the name of the currently active state for debugging purposes. It's not important for the logic of state swapping. We will have one class for each state. The first state will be sit-in, which will also be special because it will stop the game from scrolling as the player sits down. We will export it, so export class sit-in. Constructor will take a reference to the player object as an argument so that it can access properties on the player class. I am extending a class and I want the code from this constructor on the parent to run as well, so I have to call super keyword here, the trigger constructor of its parent class, also known as a superclass. We can see that the parent class constructor expects a value for state. This is simply for monitoring purposes. I will pass it word sitting and it will get converted to this.state property here. Only after we called super we can use this keyword here. In a child class, if we use this keyword before using super, we will get an error. Super on child class always needs to be called before this keyword is used. Each class will have enter method that will run once when this state is entered, and handle input method that will take input as an argument, and it will keep checking if the correct key is pressed, and it will switch player to a different state when that happens. For example, it will switch to jumping state when we press up arrow key. In player.js, we will need 3 helper properties to apply state design pattern. Let's just write them and I will explain in a minute. We will need a property called this.states, which is an array of values. We will also need this.currentState, which will point to indexes in this array. When the player object is initialized for the first time, we will call its enter method to activate its initial default state. I'm exporting my sit-in class here. Let's import it up here in player.js. I import the entire sit-in class from player.states.js. Quick overview of how we will apply state design pattern into our codebase today. Player object will have this.states property, which will be an array containing individual states such as sit-in, running, and so on. The player can only be in one state at a time, so we will have another property here called this.currentState. When this.currentState is equal to this.states, index 0, player is sit-in. When it's this.states index 1, the player is in the running state, and so on. The final piece of logic will be that each player state is actually its own class. We will have a class for sit-in, another class for running, there will be a separate class for every state. The reason for that is that each state needs to have its own separate enter method that will set speed, animation row, and everything else that needs to be done whenever the player enters a new state. Each state class will also have a handle update method, which will listen for keyboard inputs, and it will be ready to switch the player to a different state whenever the correct key is pressed. Because all state classes have their own enter and handle input method, and because this.currentState points to different states as the player switches from one state to another, we can just keep calling this.currentState.handleInput, and we will get different behaviors depending on the current state the player is in at that point in time. And this is the entire logic behind state design pattern. If it's still not clear, don't worry, I will go over it today step by step as we write the code. It will make more sense if you practice and code with me. Inside this.states array, I will instantiate each state class. Right now, I'm creating an instance of sit-in class. Here on line 14, in player.states.js, I can see that it expects a reference to the entire player object as an argument. Because here we are inside player class, I pass it this keyword, which references this entire player class. When we enter sit-in state, I want to draw a different animation row in player sprite sheet. Let's set up sprite animation. We will have frame X, horizontal frame, that will cycle from left to right, animating the player, and we will have frame Y, which will travel in the sprite sheet vertically whenever we switch to a different state. You can see that frame Y0 is standing, frame Y1 is jumping, and so on. Changing the values of frame X and frame Y will jump by the width and height of a single frame so that we can animate the sprite sheet. In draw method, I replace hard-coded coordinates 0, 0, which are currently displaying this top left frame, to dynamic values. Source X value will be this.frameX times the width of the player frame. Source Y will be this.frameY times the height of the player frame. I'm getting a console error. It's because I forgot a / here on line 1 in player.js.
Now it's fixed. So now frame X cycles horizontally, frame Y travels around the sprite sheet vertically. I can see that the sit-in animation is frame Y 5. When we enter sitting state, I take this.player from line 16, which points towards the player object, and I set its frame Y property to 5. I could have defined getters and setters on the player object to do this by the book, but I don't think it's necessary for our purposes today. This code will work well. Back in player.js, I set the initial frame Y to 0, which is this stand-in animation. Now I need a method that will allow us to switch player between states. I define it down here on the player class. I will call it, for example, setState. It will take this new state we are about to switch to as an argument. It will be a number corresponding to indexes in this.states array from line 17. Inside, I set this.current state from line 19 to one of the states from line 17, depending on which index I pass to it. Right now, we only have one element in the array, the sitting state, that's index 0. If we have more state classes in the array on line 17, I will be able to swap to index 1, 2, and so on to switch player to those states. Keep in mind, setState will take one argument called state, which will be a number, corresponding to the index in this.states array. Then we call enter method on the currently active state to set up things like speed, sprite animation, and so on. There's also handle input method we defined here. Enter method will run once every time we enter that state. Handle input method will be running 60 times per second, waiting for keys to be pressed so it can switch the player into a different state, when the user requests it by pressing the right set of keys. In our case, mostly arrows so far. I will be calling it from inside update method on player class here. So this.currentState.handleInput. I'm passing input value as an argument to the update method here. The value of input is coming from update method on game class, pointing to keys array on an instance of input handler class from line 15. This way, player update method can always see what keys are being pressed in our game by checking if they are present in this input keys array. We defined it before here on line 3 in input.js if you remember. We pass it through game class to update method on player class, and I will just pass that argument along to handle input method like this. This code will be running 60 times per second, constantly checking what keys are present in input keys array. Handle input expects keys array here as an argument. I called it input, and we will be checking and waiting for specific keys to be pressed. The main function of state design pattern is that we are basically locking player object in one state at a time, and while the player is in a certain state, it will only react to a limited number of keyboard inputs. While the player is in the sitting state, we will react to arrow left and arrow right keys, and when they are pressed, we will switch into running state. So I say if this input value that was passed as an argument, which points to this.keys array on input handler class, if that array includes arrow left key, or if it includes arrow right key, call setState method on player object. Here we can see that setState method expects state as an argument, and it will set the current state of the player to that index in this.states array from line 17. Right now, that array has only one element, so it will only work when I pass it index 0 as a value of this state argument here. It will then call enter method on that new state we just switched to. Back to player states.js. So now we know that we have to pass this setState method a number that will be used as an index in player states array to correctly switch it into that state. I can pass it number 0 here, but we have this enum object here to convert numbers to words like sitting and running to make our code more readable. The order of states in this enum must be exactly the same as the order of states in this.states array on line 17 inside the player class. Index 0 is sitting state because it's the first element in the array. This enum also needs to have the value of 0 paired with sitting, which it does. Now I can call setState, and instead of passing a number 1, which would also work, but it would be less readable, I pass it states from line 1 dot running, which has a value of 1 behind it as well. I hope it's a bit more clear. This is the most complicated part and we just covered it. Just keep coding with me and it will start making more sense. Right now there is no index 1 in this array yet. We need to create a running class to add it. I copy this code block and I rename it to running.
and I also put run in here. I check the sprite sheet and I can see the fourth row in the sprite sheet is running. So I set frame Y to 3 because we count from 0. In handle input on running class, we will listen for arrow down, and when it's pressed, we switch player to the sit-in state. We are exporting running class here. I import it up here in player.js, and I instantiate it as an element with an index of 1 inside this .states array. Nice, so now when we are in the sit-in state and we press left or right key, we switch into the run-in state. When we are in run-in state, we listen for arrow down key, and when it's pressed, we switch back to the sit-in state. Perfect, we have all the logic for swapping states in place. Let's add a jump-in state. Again, I copy this code block, I rename it to jump-in, and I put jump in here. I comment out line 31 inside player.js that we used for jump-in before. Let's refactor it. When we enter jump-in state, we set frame Y to 1. If the player is on ground, that method comes from line 39 in player.js. We set velocity Y on the player to -30, pushing it upwards. As we discussed in part 1, during a jump, velocity Y goes from -30 to 0, moving the player upwards, and then as it moves into positive numbers, the player will start falling down. We have a nice falling animation row in our sprite sheet, so let's switch the player into falling state when it reaches the peak of its jump. Instead of listening for key presses, we can also check for values of properties on the player. When velocity Y switches to the positive values and is more than player weight, more than 1, we know the player is falling down at that point, so we set state to states.fallen. That will point up here, so I add fallen in our enum and I give it a value of 3. We have our new jump-in state, but there is currently no way to enter jump-in in our game. We can enter it from run-in state, for example. When the player is in the run-in state, we already listen for down arrow key. We will also be checking for up arrow like this. If input includes arrow up while the player is running, set state to jump-in, so value 2. Now I copy jump-in state and I rename it to fallen. I give it a text value of fallen in here. While we are falling, we won't be listening for any keys. We will just wait for the player to be back on the ground, and then we set state to running. We are exporting jump-in class on line 46 and falling class on line 62. I import them up here inside player.js. Then I instantiate both of these classes inside this .states array. The order in which you do that is important, and it needs to be the same as states enum we have on line 1 inside player.states.js. Those indexes have to match. You can see I'm importing jump-in as index 2 in this .states array. Fallen is index 3, and here inside enum object, jump-in has also the value of 2 and fallen has value of 3. It needs to match. While we are inside the sitting state, we can press arrow left and arrow right, and it will switch player into run-in state. While we are inside run-in state, we can press arrow down to sit or arrow up to jump. To keep things simple, I can also check for arrow left and arrow right here inside update method, because I want the player to be able to move left and right in basically all states when the arrows are pressed. The controls feel better that way. That means we can move left and right in the air even while we are jumping or falling or rolling. When I'm in the run-in state, if I press up arrow key, we jump, and when we reach the peak of the jump, we get automatically swapped into a falling state. When we hit the ground, we automatically switch into run-in state. Great! I adjust this minus velocity y value to change the height of the jump. Well done if you followed the code all the way here. Now you know how to apply state design pattern, which is quite an advanced technique, especially if you are a beginner. We will add more states to it soon, but before we do that, let's properly animate the sprite sheet of our dog. I want it to animate and move. I delete this line of code. We will handle sprite animation in this area, inside update method on player class. We have frame x property, which holds the index of horizontal frame. We have frame Y, which refers to the vertical position in the sprite sheet. You can see that different rows have different number of frames. I want to rotate between frame 0 and max frame on that row, depending on which row we currently are on. Sit-in state and run-in state have different number of frames. We will hold that value in this .maxFrame property, and we will adjust its value every time we swap states. Since we have our code nicely organized in state design pattern, it's easy to do that and to keep track of each state separately. Let me show you. So to animate each row, we will always cycle between frame 0 and max frame on that row. If frame X is less than max frame, increase frame X by 1. Else, reset frame X back to 0. It's going too fast and it's blinking for sit-in state because we are including empty frames. It's animating so fast because this particular sprite sheet was designed for lower frame rates. It really depends on which art assets you are using, but it's also easy to control FPS of sprite animation independently of the FPS of the entire game. I can, for example, have the dock sprite sheet animate at 10 frames per second while the entire game is still updating at 60 FPS. You can do it by checking animation timestamps and calculating delta time. It's easy, let me show you. I will explain it right now. We will need a helper variable here. Last time will hold the value of the timestamp from the previous animation loop. Request animation frame method has two special features. First, it automatically adjusts the screen refresh rate, so most of us will get 60 animation frames per second, unless you have some gaming high refresh screen. Request animation frame also auto-generates a timestamp value, and it automatically passes it as an argument to the function it calls, in our case animate. I can assign it a variable name here. I will call it timestamp, for example. So this timestamp is auto-generated by request animation frame every time it serves a new animation frame, every time it loops. I will use it to calculate so-called delta time. Delta time is the difference in milliseconds between the timestamp from this animation loop that was passed here and the timestamp from the previous loop. It will give us the value of milliseconds for how long each frame stays on the screen before it gets redrawn. Last time will always hold the value of the timestamp from the previous loop, so when we used it to calculate delta time, we override last time with the value of timestamp from this loop so that it can be used to calculate delta time in the next loop. This might be a bit complicated to understand at first, but don't worry, it will make more sense as you use it more often. For this to work, timestamp gets auto-generated only when it's called by request animation frame, so for the very first initial call of animate, I have to pass it some value for timestamp. I will pass it 0. I console log delta time and I can see that it's around 16.6 milliseconds, which is around 1000 milliseconds divided by 60. My frame rate is 60 frames per second. Perfect. Yours should be similar. The value of delta time calculated this way depends on the power of your computer and on the refresh rate of your screen. So as the animation loop runs, we are recalculating delta time over and over. Every time we calculate it, we pass it the game update method. Up here on line 17, I make sure update method expects that argument. I want that delta time value to be used inside player class, so I pass it along to player update method as the second argument here. Inside player.js, we make sure that it's expected. So now the player class has access to delta time value. We know how many milliseconds it takes to serve the next frame. We can use that value to adjust sprite animation speed, for example. We can say only serve the next horizontal frame in the sprite sheet every 50 milliseconds or something like that. We can get complete control over that frame rate. It's simple. Let me show you how. This particular dock sprite sheet works the best when it's been animated at 20 frames per second. I will need a number of milliseconds for how long each frame should stay on the screen. If the frame rate is 20 frames per second, one frame should stay for 1000 milliseconds divided by this.fps divided by 20. Frame timer will cycle between 0 and frame interval, increasing by delta time for each frame. Every time it reaches the interval, it will trigger the next frame and it will reset. We will handle that logic here. If this frame timer, which starts at 0, is more than frame interval, set frame timer back to 0 so it can count again. When that happens, also serve the next frame X, horizontal frame, in the sprite sheet. Else, keep increasing frame timer by delta time until we reach that frame interval value. Perfect. Now you know how to control FPS in the game. The sprite sheet of our dog is animating at 20 frames per second. You can see it's blinking. It's because we are animating this empty frame here. For sitting animation, max frame isn't 5, so I remove this value. When we enter sitting state, we set max frame on player class to 4. We count from 0. When max frame is 4, we are not seeing the whole running animation, so I set max frame inside running state to 6. I will also swap max frame and frame Y to prevent occasional blinking if we swap states too fast. In jumping, max frame is 6 and falling is also 6. Now we are correctly animating each state. Do you see how it's easier to keep the code organized when we separated each state into its own class? Occasionally we can get a situation where we swap state and frame X is currently too high and that row doesn't have that many frames, so we get a quick blink. To prevent that from happening, every time we enter a new state, we set frame X back to 0 before we swap to a different vertical sprite row with frame Y. It's just a small thing. We have complete control of FPS, how fast we serve frames in player sprite sheet. I can come here and set it to 5. The great thing is that the player still moves at 60 frames per second, but the sprites are animating at 5 frames per second. We can control these two things separately. It would be very bad if controls reacted so slowly, but maybe you have a sprite sheet in your game that was designed for lower FPS. Our sprite sheets were designed for speed around 20 FPS. Depending on what art assets you are using for your game level, you might not want the player to be standing all the way at the bottom of the game area. Sometimes you need to adjust this value. Today I will give you all art assets to use, so I know we will need to create some margin on the bottom. That margin will have to be considered in more than one place around the codebase, so let's put it in the main game class so it's easy to access. I want the ground level to be 50 pixels from the bottom edge of canvas. This .ground margin is 50. Inside player.js we have access to it through this .gameReference, so the initial vertical coordinate will be height of the game minus the height of the player minus ground margin, like this. This will not work because here I am creating player before I declare that class property. I need to put it up here, so it's available at the point when the player is created. That worked. I also need to adjust this on ground check, because being on ground now also involves this ground margin. Perfect. You can adjust ground margin value to match the environment in which your character is currently moving in. Our environment will be an abandoned monochrome city. You can download all art assets in the video description. If you are a beginner, I suggest you use my art assets first and get the game to work before you start adjusting it to your own version. It will save you a lot of headache if you encounter some unexpected challenges, because you can just look at my code to fix it. We will be animating a parallax multi-layered background. I made a special episode about this if you want to go more in depth at a beginner-friendly pace. We built a small standalone project in there showing all the concepts and alternative approaches. Let's use the quickest version here. So we have a new file I called background.js. I will need two classes here, helper layer class that will handle logic for each state separately, and main wrapper class. I will call, for example, background that will be exported and animated from the main game class. It's actually quite simple, let me show you. Layer class will need access to the game object because we need to be constantly aware of width and height of the available game area. We will also need the width and height of the actual background image. We will need speed modifier argument because each layer will move at a different speed, but relative to the current game speed. The last argument will be an image. Each layer will have a different image. All 5 images are available to download in the video description. I might also include some alternative art assets in there for experiments later. As usual, we convert the arguments that are passed to layer class constructor into class properties. Each layer will also need X and Y position, update method to move it, and draw method to draw it on canvas. You know how it goes now. I try to keep similar code structure across all classes for clarity. I could also name these methods something else if I wanted to. The background images we use today are seamless, which means that when they are scrolling from left to right continuously, we can't see where they end and where they begin. There is a small simple trick to create an illusion of endless background in a side-scroller game, and we are about to learn it right now. Click the like if you are getting any value today. We will be updating horizontal x coordinate. Vertical y coordinate will always be 0. If this.x is less than minus its entire width, which means it has scrolled all the way behind the left edge of the game area and now is hidden, reset it back to 0 so it can scroll again. Else, keep decreasing x by the current game speed times speed modifier, because I want each layer to move at a slightly different speed for parallax effect. Game speed doesn't actually exist yet, so I declare it here on line 15 inside main.js. Let's set it to 3 pixels per frame, for example. Draw method will need context as an argument to specify which canvas element we want to draw on. We call built-in canvas draw image method again. This time we don't need the longest version with 9 arguments. For backgrounds we just need to pass it 5 arguments. Image we want to draw, x and y where to draw it, and width and height of that image. So this is a helper class that will handle logic for each individual layer. Our parallax background will have 5 layers. We create and combine them together in another class I call, for example, background, and I will be exporting that class. It will need access to the main game class because we need its width and height and game speed properties. I'm providing you images of a specific size for this project. The width of each layer image is 1667 pixels and height is set to 500 pixels. I made those images the exact size we will draw on canvas for performance optimization reasons. You can also use larger images and you can scale them down with code, but that will take more computing power and it can affect the FPS of your game. Let's bring all 5 images for our layers into the project. This.layer5 image is equal to layer 5. If you downloaded the project images and placed them inside your assets folder, you can go ahead and inside index.html bring them into the project. Image element with an ID of layer 5 and source assets/layer-5.png. I also bring layer 1, 2, 3, 4, 5 like this. In style CSS I give all of them display none. We don't want to draw the actual image elements on the website, we want to draw them on canvas. As I said before, JavaScript automatically creates references to all elements with an ID in the global namespace, so I can just pull the images in using its auto-generated variable name like this. It would work like this, but I noticed more people are comfortable using getElementById in here, so I will do that. We will also need an array that will hold all background layers, so I created here. And here inside background class constructor I will create an instance of layer class from line 1. I call it, for example, this.layer1 and it will be equal to new layer. You can see it expects 5 arguments, so I pass it this.game, this.width, this.height, speed modifier will be 1 for now, and the image will be this.layer5 image from line 25. Now we have one instance of our layer class. Let's put it inside background layers array. I give it update method and inside I take that background layers array and I call for each array method on it. For each layer object in the array I call its associated update method. I also do the same for draw method. And I pass it context because we know it expects it up here on line 15. Let's see if it works. I import the new background class up here in main.js. I instantiate it inside game class constructor and I pass it this keyword as a reference to the entire game object because I know it expects it here. I have my background now, so I can call its update method. I get an error. We will fix that in a second. I will also call draw method on the background and I call it before I draw the player because I want the background to be behind the player, and I pass it context. So we have an error somewhere inside our background class. The first typo I made here probably already noticed. I need to use this dot here to correctly point to the instance of layer class. Now we get draw image error, so I know something is wrong with the way I'm linking my image. If I check here, I can see I misspelled the name. It's supposed to say this.layer5 image. Nice, we are animating our background layer. I can adjust ground margin to move the player a bit up to match the background artwork. The trick to create seamlessly scrolling backgrounds is to draw the same image twice next to each other, so one at the position X and the other at the position X plus this.width, like this. I give it additional plus 20 so that we can see where the second one starts. Here. So what is happening here? We have two identical images scrolling side by side. When the main image one scrolls all the way off screen, we quickly reset it so that it can scroll again. Image 2 is never fully visible. It's just there to fill the left gap before the first image has a chance to reset. I hope this visual makes it clear what's happening. And now you know the secret of endlessly scrolling seamless backgrounds. It's easy. Let's make them parallax, which means it has multiple layers that move in slightly different speeds to create an illusion of depth, of distance. I already brought those images into our project in index.html, so I just turned them into class properties here. I instantiate each layer class with its associated image. I put all those layer objects inside this .background layers array so we can cycle through all of them at once using for each method, inside update and draw. Now we are animating all layers at the same speed. I can give them different modifiers. Layer 1 is just gray sky, no need to move it at all, so its speed will be 0. The speed of layer 2 will be game speed times 0.2, layer 3 is game speed times 0.4, layer 4 will move at 80% of the current game speed, and layer 1 will move at the same speed as the actual current game speed. Perfect! You can see that if I change the modifier even higher, it gives us faster scrolling. Since we connected everything to the current game speed, I can change the scrolling speed of the game when the player switches to a different state. Maybe I want the game to stop scrolling when the player sits down, and I want double scrolling speed when the player does a special attack or a roll. There are many ways how we can structure the code at this point. I can either bring a reference to the main game object into player states so that we can manipulate game speed property from there, or I can, for example, do it from within setState method on player class, because from there we already have access to game speed. I will give setState a second argument called speed. Inside, I set speed property on game object to the speed value passed as an argument. At first, the speed of the game is 3 pixels per frame. Since we start in the sitting state, the initial game speed should be 0. In player set state, whenever I set state, I will also set game speed. I might refactor this later, maybe it's not the best solution, but it should work. Let's see. When we are running, game speed will be 1. Sit-in, game speed 0. Jump-in, game speed is 1. Fall-in, also 1. Run-in, 1. I save all unsaved changes in all my files. Now, the game stops scrolling when we sit, and it starts scrolling again when we start moving. We can refactor this to make this code a bit better. On the game class, I create a new property called this.maxSpeed, and I set it to 3. I set this.speed to 0 at first. Inside setState, we set the current speed to max speed times the speed that was passed to setState. That way, I can adjust the actual game speed by adjusting just the max speed property on the main game class, rather than adjusting the values we passed to setState in all those places in playerStates.js. Now we have quite a lot of logic going on. If you are a beginner, well done. You should be really proud of yourself if you managed to follow along. This was the most complicated episode in this entire project. The rest will be relatively easy when you understand the tips and tricks I'm about to reveal. It's important that player feels like they have control over the character. Quick responsive controls add a lot towards positive user experience.
We are building a fast-paced animated 2D game with plain vanilla JavaScript and HTML canvas element. We applied state design pattern to animate our player. We have endlessly scrolling parallax backgrounds where scrolling speed reacts to player movement. Today we will learn how to make our game more fun by adding 3 very different enemy types. Are you ready to take our dog for an adventure and help it find its way home while avoiding enemies and creatures of the dark? Let's go! I create a new file called enemies.js, and inside we declare a custom JavaScript class I call, for example, enemy. I will have a constructor, and inside I declare this.frameX, which will handle horizontal spritesheet navigation, and frame_y will navigate in spritesheet vertically. The spritesheets we will be using are optimized for 20 frames per second, so we will control them with timestamps and delta time again. So 3 helper variables: FPS, frame interval, and frame timer. It will work exactly the same as it did in player class. We will also need update method to move enemies around and draw method to actually draw their sprite sheets. I want to create multiple different enemy types. To keep our code organized and easy to navigate in, we will use a JavaScript subclass in, which means we will have a parent enemy class that will define properties and methods shared between all enemy types, and we will extend that parent class into multiple different subclasses. Each subclass will have properties and methods, behaviors, that are specific just for that enemy type. So enemy is so-called parent class, also called a superclass, and we are using this special extends keyword to create 3 child classes, also called subclasses. JavaScript actually doesn't have classes, this is just syntactical sugar, modern, cleaned and simplified JavaScript syntax. Behind the scenes, this code is just setting up prototype chains using JavaScript inheritance. It just looks cleaner and easier to navigate in if you write your code this way. So we have a parent enemy class and 3 child classes called flying enemy, ground enemy and climbing enemy. All 3 child classes are using extends keyword pointing towards their parent enemy class. This will automatically set up prototype chain behind the scenes, and all these classes will have access to properties on their parent class and also to this update and draw method. That way we can avoid code repetition and we don't have to redeclare methods and properties that are shared across all enemy types. Inside each subclass we will only define what's unique about them. I will show you exactly how this works as we create 3 unique enemy types with very different behaviors and movement. Click the like if you are getting any value. Let's start by bringing images into our project. In the video description I will give you sprite sheets for many different enemy types. For now we will use just 3 of them. If you are a beginner, you should maybe use the same ones I'm using, and when you have a fully working code base, you can play with it and use your own custom sprite sheets. We will use enemy fly, enemy plant, and this big spider. I will hide images with CSS because we want to draw them with JavaScript on canvas. There is one more thing we have to understand when extending JavaScript classes. There is a special keyword called super. It's used in 2 different ways because we can extend code from parent class constructor or we can extend a method from the parent class. I will show you how to do both as we create different enemy types with different behaviors. I have flying enemy subclass that extends this enemy superclass. When I create a new flying enemy, I want to run all this code from parent class constructor, and then I want to add some additional properties that are specific only to the flying enemy. I do that by first calling super like this. This will automatically run all the code from here. While extending classes, I can only use this keyword after I used super. If I use this keyword before super, I will get an error. Flying enemies will need access to the entire game object because they need to be aware of game area width and height so that they know when they are off screen. I will pass game as an argument to the constructor here and I will convert it into a class property as usual. Each enemy type will also need width and height, but because each enemy type has a different size, I couldn't put these values on the parent class. Width and height will be declared here. I look at my fly sprite sheet and I can see that the width of a single frame is 60 pixels and the height is 44 pixels. Each enemy will also need starting X and Y coordinates. Flying enemy will start at a different position than a ground enemy, so X and Y properties will also have to be on the child class, not on the parent class. Speed X will be horizontal speed and max frame on our fly sprite sheet is 5. By the way, all my flying enemies will be flies for now, but I could also have multiple flying enemy types. I can have flying enemy class that extends parent enemy class, and I can have a bird, fly and ghost classes that extend flying enemy class. We can go down multiple levels if we want to. In that scenario, flying enemy class would only have properties and methods shared between all enemy flyers, and things like width and height, speed X or max frame would be declared separately on each subclass because each enemy will have different sprite sheet. We are keeping our code modular and well organized so that it's easy to make these changes later if we want to. Inside update method on the parent class we will handle movement. For every animation frame, I want the horizontal X coordinate of the enemy to be increased by its speed X property. I will do the same for vertical Y coordinate and speed Y property. We will also handle cycling through sprite frames here. It will work exactly the same as it does for our player sprite sheet.
Update method will have access to delta time, difference in milliseconds between the previous and the current animation frame. If frame timer from line 7 is more than frame interval from line 6, we reset frame timer back to 0 so it can count again for the next frame, and we serve the next horizontal frame in the sprite sheet. Or if we are at the last horizontal frame, we reset back to frame x 0. Else, meaning frame timer is not yet higher than frame interval, we keep increasing frame timer by delta time until it gets there. Draw method will expect context as an argument. Inside, we will draw enemy sprite sheet using canvas draw image method. It will need 9 arguments. The first argument is the image we want to draw. I will hold a reference to that image in this .image property. Since each enemy type will have a different sprite sheet, it needs to be placed here on flying enemy class. I use getElementById and I will point it towards this img element with an id of enemy underscore fly from line 19 in index.html. So drawImage expects 9 arguments in this case: the image we want to draw, source x, source y, source width and source height of the rectangle we want to crop out from the source sprite sheet, 1 frame, and destination x, destination y, destination width and destination height to specify where to place that image on destination canvas. It will work exactly the same as it does with player. We already explained before how frame x multiplied by the width of a single frame travels sprite sheet horizontally. Source y argument will always be 0 because enemy sprites will only have 1 row. So we have image to draw. These 4 values define what to crop out. These 4 values define where to place that cropped out image on canvas. As I said before, we can extend parent class constructor using super keyword. We can also extend a method from a parent class. In this case, I want to have update method on flying enemy type. I want it to first run all the code from update method on the parent class, and then I want to add a little bit of code that will be specific only for flying enemies. Update method will expect delta time as an argument. I will call update method on the parent class from line 9 by saying super, referring to its superclass, .update, and I pass this delta time long because it's expected here on line 9. Doing that will first run all the code between lines 9 and 19. That code will be shared for all enemy types. After I run that code, I will add a little bit of code that will be specific only for flyers. I can make them do so many different things here. I made a special episode focusing only on enemy movement patterns before. Let's just pick one. Maybe I want vertical wavy movement. Before we do that, let's actually add some enemies into the game to see how the movement changes. Let's make sure we are exporting all our child classes. I imported them up here inside main.js. I want to periodically run some code that will add enemies in a specific interval. I will declare that code in a special method on game class. I call it, for example, addEnemy. We will need some helper properties to build this functionality. This .enemies will be an array. It will hold all currently active enemy objects. Every time addEnemy method runs, it will take this array and it will use built-in JavaScript push method to push one new enemy in there. Push method adds one or more elements to the end of an array and returns the new length of the array. We want to push one new flying enemy in there for now. We are importing flying enemy class here from enemies.js, and here I can see flying enemy class constructor expects game as an argument. So down here in main.js, I'm creating an instance of flying enemy class and I pass it this keyword as an argument referring to this main game object. We will handle enemies here inside update method on game class. Similar to how we use delta time to periodically serve the next frame in our sprite sheet, we will have timer and interval helper variables to periodically add enemies into the game. Enemy timer will start at 0. It will be increasing by delta time. Every time it reaches a value in enemy interval, we will add one new enemy into the game and we will reset enemy timer back to 0. Let's say I want to add a new enemy every second, so 1000 milliseconds. Let's write that logic in code. If enemy timer from line 23 is more than enemy interval from line 24, call this .addEnemy custom method from line 38. And also reset enemy timer back to 0 so it can count again towards the next enemy time. Else, keep increasing enemy timer by delta time until we reach enemy interval again.
Let's put a console log inside add enemy to see if it's working. I will console log this.enemies array from line 22. Nice, you can see as the game runs, every second, one new flying enemy object is added into enemies array. Perfect. So all our enemies are held inside this.enemies array. I will run through the array and I will trigger their update method to make sure they move around. For each method, executes a provided function once for each array element. I will use fat arrow ES6 syntax here. In the callback function, I just trigger update method on each enemy object and I pass it delta time from here, because I know it's expected there. I will do the same thing inside the draw method. I will cycle through all enemy objects and I will trigger their draw method. I pass it context as an argument. I don't see any enemies coming. Let's try to use minus equals here to make them move to the left. Still nothing. I'm console logging enemies array, so let's check the console. I open up the array. Let's change the initial x and y coordinates to 50-50 now. If I open the array again and I check one of my flying enemies, I can see their vertical y coordinate is none, not a number. JavaScript doesn't know where to draw them vertically. Let's track the problem. I define vertical y coordinate correctly on line 33, but as the game runs, I'm increasing it by speed y property here on line 12. Speed y doesn't exist, so as a result we are breaking our code. I will define vertical speed y property on my flying enemy class. Let's set it to 0. Nice, we have enemy flies moving from right to left from the initial starting coordinates 50-50 as defined here. I actually want them to start from the point just behind the right edge of available game area, so the initial x coordinate will be this.game from line 29.width. Nice. I randomize vertical y coordinate to spread them around. I want them to only move in the upper half of the game area, so math.random times this.game.height times 0.5. In console you can see we have an endlessly increasing array as more and more enemies are being added. I actually want them to be removed when they fly past the left edge of screen. I will check if enemies are off screen in this area. If horizontal coordinate of the enemy plus its width is less than 0, meaning it's completely hidden behind the left edge, set its marked for deletion property to true. This property will be shared for all child classes, so I can define it only once up here on the parent class. Initially I set it to false. So we are adding new enemies. They fly from right to left. When they are hidden behind the left edge, we are setting their marked for deletion property to true. Here inside update method on game class, in the area where we handle enemies, we are cycling through every object in enemies array, triggering their update method. At the same time, I will also check if their marked for deletion is true, and if it is, we splice it out of the array, removing it. Splice method needs two arguments, in this case. Index of the element we want to remove from the array, so index of this enemy with marked for deletion set to true, and how many elements to remove at that index. We want to remove only one element. Now I check in the console and I see that new enemies are being added and old enemies are being correctly removed. Perfect. Let's play with the movement a little bit. I can do so many things here and there's a special episode about it. I can, for example, randomize their horizontal speed x value so that each enemy flies at a slightly different speed. Let's try a random value between 1 and 2 pixels per frame. I can also randomize their initial x coordinate so that we get even more randomness in their spacing. When the player starts running, it becomes obvious we need to account for the current game speed when making enemies move. Up here on line 12, I just include game speed in horizontal position calculation. I actually need to use plus here. Now, when the player moves and when it stops moving, the enemies are always positioned correctly in relation to our dynamically scrolling game world. We made a lot of progress today. If you are still following, well done. These are all fundamentals of 2D game development. I hope you are getting some value out of this. So the flies are moving in a straight line from right to left. What if I want to give them a wavy up and down wobble as they move? It's easy. I will need two helper variables and these will be specific only for flying enemies, so I declare them down here. Angle will start at 0 and we will be increasing it slowly and feeding it to math.sine method, which will map it along a sine wave. It will be increasing by this custom VA value, velocity of angle, and it will be a random value between 0.1 and 0.2. Inside update method on flying enemy class, I first trigger all the code from the parent enemy class, and I will add some extra custom code that will be specific only for flying enemies. For every animation frame, I will increase angle by VA value. And then I update vertical y coordinate by math.sine of this ever-increasing angle value. Passing a slowly increasing angle to math.sine will map positions of our enemies along a sine wave. We can also create a circular movement by using math.cosine on horizontal x coordinate. For now, let's leave it like this. We have our flying enemy type, perfect. Let's create a ground enemy. It will be a plant, so it will have different behavior. It will be much simpler to implement. Let me show you. Class ground enemy extends enemy, so again, this class will automatically inherit everything from the parent enemy class we declared up top. The only properties we will declare here are the ones that are specific to ground enemies. Shared properties will be inherited automatically because of this extends keyword. Constructor will expect game as an argument and we convert it to this.game property. The width of a single frame is 60, height is 87 pixels. Initial x is just behind the right edge of canvas, so this.game.width. We want the enemy to be sitting on the ground level of our game world, so vertical y coordinate will be game height minus height of this enemy minus ground margin. Image will point towards enemy plant image from index.html. Horizontal speed will be 0 and vertical speed will be also 0. This is a plant, it won't move around. Sprite sheet is very simple, it has only 2 frames. Max frame is 1 because we count from 0. If I don't declare update and draw methods at all on ground enemy class, JavaScript will automatically travel up the prototype chain and it will find update and draw method on the parent enemy class. In main.js, inside add enemy function, we only want to be adding ground enemies when we are moving. If we are sitting down, we don't want the game to keep adding new ground enemies because they would just be accumulating off screen. We only want to add a new enemy if game speed is more than 0, when the game is scrolling. And also I don't really want to add it every 1000 milliseconds. Every time add enemy method runs, I only want there to be a 50% chance that we add one, so math.random is less than 0.5. Math.random code like this returns a random value between 0 and 1, so a value lower than 0.5 should occur on average 50% of the time. So every time add enemy method runs, we always add one flying enemy, and if the game is scrolling and this 50% check is true, we also add one new ground enemy. I get an error which tells me I forgot to call superclass constructor on my subclass. Easy to fix. Like this. Nice, we have a ground enemy in our game. I can see there is a small wobble between enemy plants and the ground texture. I'm not really sure what's causing it now. If you know, let me know in the comments. We will fix this later. Let's add a climbing enemy. Climbing enemy will be a big spider, suspended from a web. I showed you how to extend update method to make our flies move in a different pattern. I also showed you how it works when you don't need to declare any additional update and draw methods with the plant. Now I will show you how to extend the draw method and how to add some additional graphics, in this case spider webs. Constructor will expect game as an argument. We call super to trigger class constructor from the parent enemy class. This.game is game as usual. Width of a single frame is 120, height is 144 pixels. The initial starting coordinate is behind the right edge of canvas, so this.game.width. Vertical y coordinate will be a random position in the top half of the available game area. Image will point to the big spider image we linked earlier in index.html. Horizontal speed x will be 0. Our spiders will be moving up and down vertically. Vertical speed y will be either +1 or -1 depending on this math random check. This is so-called ternary operator. We are using it as a simple one-line if-else statement. If math.random is less than 0.5, which should be roughly in 50% of cases, set speed y to 1, else set it to -1. So if condition is true, question mark, return this, else colon, return this.
This will make sure some spiders are moving up, some are moving down when they initially spawn in our game. Max frame of spider sprite sheet is 5. Update method will take delta time as an argument. It will first call update method on its parent enemy class to run all the code from there. We will also do the same thing for draw method like this. Here I'm checking if game speed is more than 0 and if random check is less than 0.5, and I'm adding a new ground enemy. I'm going to add else if here, and if this random check is false, and at the same time if game speed is more than 0, we will add one new climbing enemy into our game. Now every second we always get one fly, and we get either one spider or one plant. Nice! I'm extending update method on climbing enemy because I want to climb up and down. When it's moving down and it reaches a bottom boundary we defined here, I want it to kinda bounce and start moving in the opposite direction upwards. Let's make it move upwards whenever it climbs all the way down and touches the ground level. So if vertical y coordinate is more than game.height minus height of this spider enemy minus ground margin, set its vertical speed to its minus value, so this.speed times -1. Also, I want to set its marked for deletion to true if it climbs off screen vertically, so if this.y is less than minus height of the spider sprite sheet, set its marked for deletion to true. This spider spawned moving up. This one is moving down. When it reaches ground, it bounces and it starts moving back up. Perfect. We are also extending a draw method, so let's draw a spider web. Spiders don't fly, they should be hanging from a spider web. We are calling draw method on the parent enemy class that will handle drawing of the actual spider sprite sheet, and we will add some extra code here just to draw the spider web. I want to create a line, so I start by calling begin path. Move method will set the initial x and y coordinates of the line. I give it coordinates 0, 0 for now, the top left corner of canvas. Line 2 will define the ending x and y coordinates, so I pass it spider's current x position as x and 0 as vertical y. Now I can stroke my line. I don't see any line. Right, I need to use this.y here to move it on screen. And here's our spider web. It works. Let's make it look better. I want it to start from this.x and 0, so just above the spider. Nice, so it goes from the top left corner of spider sprite sheet upwards. I need to center it horizontally, so plus the width of the spider divided by 2, and I increase y by 50 to actually touch the spider image. Almost there, I just need to also offset the initial starting point of the line like this. I'm happy with this. If you are designing a game with multiple levels, you can, for example, have a different flyer, different ground enemy, and a different climbing enemy for each level, so 3 enemy types like this could be enough, depending on your game structure. Also, it's possible to put many more enemy types into the game and mix them together. It's up to you. I gave you all the tools you need. If you have any questions, let me know. We will learn how to handle collision detection next time. We will also apply particle effects to give the player a fire trail, and we will add 2 more states with unique animations for when the player is attacking and when it gets hit. Well done on completing the lesson. See you in the next one. We created a player, we have our game world, and we added dangerous creatures of the night. It's time to add some interactions and special moves. Today we will learn an easy way how to handle collision detection, and we will resolve collision between player and enemies in 2 different ways, depending on the current player state. If the player is rolling, enemies are destroyed and we get score points. In any other state, it's the player who receives a hit. We will also add dust particles and fire trail. If you followed any of my other creative courses, you can also use those animated trails and use them here, like you see in this demo. I like to combine game dev and creative coding. With JavaScript and HTML canvas, it's all the same set of techniques. Let's go! We have player and enemies in our game. We want them to be able to interact in different ways with each other. Let's apply collision detection. First, I want to draw a rectangle around the player and around each enemy to see their collision areas, so-called hitboxes. I go to input.js file and I delete these console logs. I want our game to have a debug mode. When I press letter D on my keyboard, we enable debug mode and collision hitboxes will be drawn. When we press D again, we exit debug mode and hitboxes will be hidden. It's very simple to implement. In keydown event, I create an else if statement. If e.key is D, set debug property on the main game object to its opposite value. If it's currently true, set it to false. If it's false, set it to true. In main.js, I create this.debug property on game class and initially I set it to true. In draw method on player class, before I draw the player sprite sheet, I say if this.game.debug is true, draw a rectangle around the player. This rectangle will be exactly the size of player's hitbox, so from this.x, this.y, player's coordinates to player's width and height, like this. Now I can go back to input.js. Here we are toggling debug mode on and off by pressing letter D. For this to work, I need to bring a reference to the main game object here. I pass game object as an argument to the class constructor and I convert it to a class property. From here we can point to the game object and toggle debug mode on and off. Finally, we know that input handler class expects game as an argument. So here on the main game class, I pass it this as an argument. Now, when I press letter D on my keyboard, we are toggling debug mode on and off. Perfect. I can also create hitboxes around enemies. Inside the draw method on enemy class, I say if this.game.debug is true, stroke rectangle around the enemy. Like this. This will work. Reference to the game object is not on the main parent enemy class, but we have it down here on each enemy type separately. Our game now has a debug mode. You can toggle it on and off by pressing D. These hitboxes represent collision areas. When the player hitbox touches any of the enemy hitboxes, I want them to interact in some way. We can have multiple different interactions. Today I will show you how to have two different interactions. When the player collides with an enemy while in rolling state, it will destroy that enemy and we get some score points. If the player is not rolling, it will get hit and it will stop its movement for a moment and play dizzy animation from our sprite sheet. We will use a simple collision detection formula between two rectangles to check if player and enemies interact. Here inside the player class, I create a new helper method. I call, for example, check collisions. Inside, we will cycle through enemies array that holds all currently active enemy objects, and as we cycle through them one by one, we will compare their x, y, width and height to the current x, y, width and height of the player object. So this.game.enemies.forEach, and for each enemy object I will run the following callback function. We will have a simple if-else statement. If some conditions are met, collision is detected, else there is no collision. To check if two rectangles collide, which means they touch or they overlap, we have to compare their x, y, width and height. Keep in mind that the way images, our sprite sheets, are drawn on canvas, we go from their x and y coordinates from the top left corner of the image to their width and height, like this. So now, player's current horizontal x position is here, and vertical y position is here, for example. We need to check if x coordinate of this enemy is less than x coordinate of the player plus player width. If this point is less or to the left on the horizontal x-axis from this point. At the same time, we check if x coordinate of the enemy plus the width of the enemy is more than the current x coordinate of the player. If this point is to the right of this point. If these two conditions are true, we know that the player and enemy are colliding horizontally. We still don't know if they collide because they could be far away from each other vertically. We will need two more checks here. We check if the enemy's current vertical y position is less than vertical position of the player plus player's height. We check if this point is above this point, and finally we check if enemy's y position plus its height is more than y position of the player, if this point is below this point. Only if all four of these conditions are true, player and enemy are colliding. Even if one of these is false, this entire if statement will evaluate to false and we know there is no collision. If we collide, we will set marked for deletion property on that enemy object to true. I will also add one more score point, so this.game.score++. I save changes and in main.js I need to create this.score property and initially I set it to 0. Now I go back to player.js, I take our new check collisions method and I will be constantly calling it over and over from up here inside the update method, like this. And we have interactions in our game. Whenever the player hitbox touches a hitbox of any enemy, that enemy gets deleted. Perfect. Whenever we destroy an enemy, we are also increasing our score, but we can't see it yet. Let's create some UI elements. I create a new file called UI.js. Inside I create a custom class I call, for example, UI, and I will be exporting it. Be careful about lowercase and uppercase letters with the word UI. Make sure you spell it the same across our codebase. Constructor will need a reference to the main game object, because that's where the current score value is stored. I create a property called font size, and I set it to 30 pixels, for example. Font family will be Helvetica. You can also use any Google fonts here. Just link them in index.html and use their font family name here if you want to, it will work. This UI class will have just one method I call, for example, draw. Its job will be to draw all UI elements and game statuses that we need. First, I declare some basic settings. Context.font will be this.font-size plus pixels space plus this.font-family. In this part, we will declare code that's specific to drawing score. Up here some more global settings. Text align will be left, and fill style for all fonts will be kept on the main game object in case we need to draw fonts from some other modules as well. This.game.font color. It doesn't exist yet, so I declare it here on line 27 in main.js file. To draw score, I call built-in fill text method and I pass it some text we want to draw, so score :space plus this.game.score. That's a variable from line 26 in main.js. And I want it to be drawn at coordinates 20, 50. We are exporting our new UI class up here, so we can import it to main.js like this. I will instantiate UI class inside game class constructor as usual, and I pass it the reference to the main game object, so this keyword. Inside the draw method on game class, I take this.ui property that holds an instance of our new UI class. Be careful about capital letters here. And I call its draw method and I pass it context. Perfect. We are drawing score and it's increasing as we collide with enemies. So this is how I like to handle drawing game text and statuses. If we want to display more information to the user, we can just add more code inside the draw method on our new UI class. We are keeping our code modular and organized today. It's easy to expand it later. I want to add more player states. We will have two different attacks and a separate state that will play dizzy animation when the player gets hit by an enemy. Let's go ahead and add them up here inside player states.js into our enum object that holds key value pairs, and it assigns each state number a more human readable value. We will have rolling state with index 4, diving state with index 5, and hit state with index 6 for when the player gets hit. I copy this entire code block and I rename it to rolling. I will also put rolling in all caps here. I check my sprite sheet and I can see that rolling animation is on the row 6, counting from 0, so frame Y is 6. I want player to start rolling when we press enter, and I want it to keep rolling as long as enter key is pressed down. Inside handle input we deal with switching states. We only want to switch player to a different state when enter is not pressed anymore. So if input doesn't include enter, and at the same time if player is currently on ground, we can exit rolling state and switch the player into running state. Else if input doesn't include enter and player is not on ground, if we stopped rolling in the air, switch into the falling state like this. We have our rolling state. Now we can decide from which states we will allow the player to enter rolling. In this case I will allow it from all states, because player can start rolling anytime. Inside handle input method on sitting class I say else if input includes enter, set state to rolling and pass it speed of 2. Rolling will increase the scrolling speed of our game compared to the regular running speed. I take this else statement and I paste it down here inside the running class. We can also start rolling when we are running. I do the same in jumping class. We can also start rolling while we are in the middle of a jump. For now I will not allow player to start rolling while it's falling. Let's see how that feels. We can always add it later. So now we have rolling with a value of 4 up here inside our enum, and we are exporting rolling class on line 94. On line 1 in player.js I import rolling and I create an instance of it inside this.states array on line 21. I get an error. It's because I didn't save changes I made to player states.js. VS Code Editor indicates that you have unsaved changes in a file with this little icon here. I go in, I save it, and now I can press enter and I can roll around. Nice work! I can start rolling from running state, from sitting state, and from jumping state. I'm testing my gameplay and I feel like I would like to start jumping while I'm rolling on the ground like this, but the game won't allow me to do that. I can't enter jump while rolling on the ground because we didn't write that behavior. Let's do it. In handle input method on rolling class, I say if input includes enter, which means we are rolling, and if input also includes arrow up at the same time, remember that our input keys array can hold multiple keys at the same time, if enter and arrow up are pressed at the same time, and if we are rolling on the ground at that moment, so this.player on ground is true, we will push player up in the negative direction on the vertical y-axis. This.player velocity y minus equals 27. Now I can roll around and I can jump up and down like this. This feels much better to play. This is a superhero dog. I want the controls and movement to feel good and quick. This dog can roll and jump around freely and the controls are very precise. Time to add some particle effects. We will have 3 different particle types in this game. Dust that comes from the ground at player's feet when it runs on solid ground, blazing fire trail when the player is rolling and diving, and a big splash of particles when we dive and stomp into the ground. I create a new file I call, for example, particles.js. Inside we will have the main parent class called particle. I will not be exporting it, it will just contain properties and methods shared between all 3 particle types. Constructor will need a reference to the main game object. Marked for deletion will be false at first. Update method will also have some code shared between all particle types. Horizontal x coordinate will decrease by the amount of speed x and game speed like this. Vertical y coordinate will be affected by speed y property. For every frame, the size of each particle will decrease by 5%. When size is less than 0.5 pixels, the particle is small enough and we will set its marked for deletion property to true. Values like speed x and size don't exist yet. I didn't declare them on the main particle class because they will have different values for each particle type. We need to make sure we define them on the child classes because if JavaScript can't find these properties when update method runs, we will get an error. So child class, I call dust, extends parent particle class. We will be exporting it. We will also have splash particles for when we hit the ground at high speed and fire particles for the attack animations. I start with the dust class. Constructor will need a reference to the main game object and x and y coordinates because the location of the particle will depend on the player's current position. We want them to appear under the player as it moves around. I call super and pass this game along because it's expected up here. This will trigger class constructor on the parent particle class, activating all shared properties. Size of dust particles will be a random number between 10 and 20. X coordinate will be x that is passed as an argument. Same goes for the y coordinate. Horizontal speed x will be a random number between 0 and 1. Vertical speed y is also a random number between 0 and 1. Color will be black. Draw method will take context as an argument as usual. I want to draw dust particles as circles, so we start with begin path. We create an arc, add coordinates this.x, this.y, with a radius of this.size. Start angle will be 0, end angle is math.pi times 2, so full circle. We set fill style to this.color and we fill the path with black color. We are exporting dust, so I will import it up here on line 1 in player states.js. Since we are using state design pattern, it makes sense we control particles from here as well because they will be closely tied to player states. I have a problem now. If I want to handle particles from here this way, I need access to the main game object. When I initially built this state management code, I thought I would only need access to the player class, but we need to go one level up and access the game object. This is why it's good to plan your code bases well before you start writing the code. I will have to do a little bit of refactoring here to make sure we have access to the main game class from within each individual player state class. Here on line 14, I pass the main state parent class a second argument called game, and inside I convert it to class property. This.game equals game. I want to replace all references to the player object with references to the game object. Game object contains the player, so I will still have access to the player object from there. Constructor on the sitting class will expect game as an argument. We delete this line with player. I pass that game object reference along to the parent class constructor as a second argument, because I know it's expected here on line 14. It will get converted to this.game class property. Now if I want to access player in these 5 places, I need to say this.game.player. In VS Code you can highlight a portion of text and hold Ctrl key down, then whenever you tap letter D, it will highlight another occurrence of that text. Using this you can select multiple lines at the same time. I tap D 4 times to select all 5 occurrences of this text, and that gives me multi-cursor selection. I can use left and right arrows to move around, and I just type game dot. I do the same in the running class. I pass it game, I remove this player line, and I pass game as the second argument to the superclass constructor. Then I select 1, 2, 3, 4, 5, 6, and I need this.game.player here in all these places. I do the same in jumping class, refactoring. Sorry, I should have planned this part better, we are almost done. I replace all 9 occurrences of this.player here with this.game.player. Falling class doesn't have much code, so this one is easy. And rolling class is the last one we need to refactor. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this.game.player. If I save this, it will break our code because our state classes are expecting game as an argument now. So on line 21 in player.js, we are currently passing this keyword, which means player object. I need to pass this.game from line 5 instead to all of them. Now we are getting some new errors, and that's because I'm passing game object as an argument, and immediately I'm triggering that state class and its enter method, but at this point the game object is not yet completely loaded, so the initial state is failing. I need to cut these 2 lines of code, and I only want to run them when the rest of the game object is ready, so at the end here. When everything is ready, including game class, player class and all state classes, we take current state property on player class and we set it to state 0, sit-in state, and we trigger enter method on the sitting state. We refactored our code and now everything is working again. We are well positioned to start adding particles through our state classes. We have a lot of console logs here. I press Ctrl F and I search for console. I delete this one on line 61 in main.js and this one on line 65. We also have a console log on line 57 in player.js. I delete it. Debugging is better with a clean console. So we are exporting Dust class here and we are importing it up here in player states.js. I will hold all currently active particles in an array on the main game object. So I created here. This.particles will be an empty array at first. Back to player states.js, I only want to add dust when the player is running, so inside handle input method on running state that runs 60 times per second, I will be pushing 1 new particle in every time it runs. This.game.particles.push, and I pass it new dust. On line 14 in particles.js, I can see that the dust class constructor expects game, x and y as arguments, so I pass it this.game from line 16. I will also be passing the current x and y coordinates of the player because I want the new particles to appear at player's current position. I close some of these JavaScript files for now to keep our workplace clean. Inside update method on the game class, after this block that handles enemies, we write our code to handle particles. On line 25 we have this.particles array that holds all currently active particle objects. We are pushing new dust particles in here from inside running state class. I take that array and I call for each. For each particle in the array, I will call their update method. If particle is small enough and its marked for deletion property has been set to true, we call splice method to remove it. Splice method will need index of the particle we want to remove and how many elements to remove starting from that index. For each method passes auto-generated index argument, so I can just assign it to a variable name here. I call it, for example, index, and I pass it to splice to identify the particle to remove. And I want to remove one element at this index. So here we call update on all active particles, and we delete old ones. Inside the draw method, I will cycle through all the particles again, and I will call draw method. One optimization tip here would be not to cycle through the same array once in update and once in draw method. I can, for example, have a utility handle particles function that does all of that. There are many ways to refactor this code. We might do it later. For now, this code will work well. You can see we are drawing our dust particles from the top left corner of the player hitbox only when we are in a running state. Nice. I will console log this.particles array to check if old particles are being correctly removed. We don't want to have an endlessly growing array in our project. That would become a performance problem soon. In console I can see that particles go up to 50 or 60, and when we stop running, the array is getting smaller and smaller until it's empty again. Perfect. I want the dust particles to come from a different point relative to the player. I adjust horizontal x coordinate by the half of player's width, like this. I will also adjust vertical y coordinate by player's height, pushing the particle's initial coordinates down closer to the game level ground. You can see how well this works in combination with state design pattern. We are only adding new particles when in running state, when player's feet are moving and touching the ground. I can go to my dust class and play with properties of the dust. I can make the particles different shape or size here if I want to. I can also give them a different color. Red, blue. It will all work. I can also do a semi-transparent color using RGBA color declaration, like this. I'm happy with this, but feel free to play with the code and adjust these effects. I came up with two different versions to animate fire for this game. I showed you both versions. This is the version with SVG filters, where we are blurring and sharpening particles to create this liquid smoke effect. I use this a lot in my generative art videos. You could actually look at any of my creative coding videos where we build trails and use that code to give your player a unique trail effect. It will be compatible with everything. Today I will do something I haven't showed you how to do before. I will use a particle image. It will be this simple flame texture. Canvas is very good and efficient at drawing images. Drawing a rectangle or an image are often two most performance efficient options for an effect like this, from my experience. You can download the fire texture in the video description. The texture is big. I will probably make the image smaller before I give it to you for download. You can also color shift the image in Photoshop to create blue or red fire trail, if it fits your level art assets. I set its display to none with CSS. We will use this image here for our fire class. Constructor will expect game, x and y as arguments. This.image will be this fire texture image. I gave it an ID of fire. Size will be a random value between 50 and 150 pixels. X will be passed as an argument, and same goes for y. Horizontal speed will be 1 pixel per frame, and vertical speed will also be 1 pixel. We have update method on the parent particle class. I will first call the code from here, so update, super update, like this. Draw method will take context as an argument, and it will call draw image. I pass it this.image from line 39, this.x, this.y, this.size as width, and this.size as height. Nice, so this is our fire class. We are exporting it, so I can import it on line 1 in player states.js. I can copy this line of code from running class that is adding new dust particles. I paste it inside handle input method on rolling class, and instead of dust I instantiate the new fire class we just wrote. Now when I roll, I'm getting a trail of fire. I adjust these properties a bit. Before we fix the position of our fire trail, let's make the individual fire texture images rotate. I will need two helper variables called this.angle, which will start at 0, and this.va, velocity of angle. It will be a random value between minus 0.1 and plus 0.1. Inside update method, I will increase angle by VA for every animation frame. We will be rotating, so to make sure the rotations don't overflow to other elements and only affect this fire particle, I will wrap this code between save and restore. This will make sure all canvas settings I declare in between will only affect this one particle. To rotate anything on canvas, first we have to translate rotation center point from its default position at coordinate 0, 0 in the top left corner of canvas over the center of the item we want to rotate. So I will translate to this.x and this.y of this fire particle. That particle is a rectangular image, so I'm translating to its top left corner. Then I call built-in rotate method that takes angle value in radians, and it will rotate everything that's drawn after this call unless we restore canvas again to its original default state. If I roll now, we are getting a spiral of small fire particles in a big circle around the player. It's because we are translating to this.x, this.y, and from that point we are drawing again to the distance of this.x, this.y here. I fixed that by setting this to 0, 0 because position of particle on canvas is already defined in translate method here. Translate method moves rotation center point and what is considered coordinate 0, 0 on canvas to the coordinates we pass to it. So because of this translate call, for these particles, coordinate 0, 0 on canvas are here in this area. I'm translating to the top left corner of each fire image of each particle rectangle. I want to center it, so I adjust this value by half of its width and this one by the half of its height. Canvas rotation can be difficult for beginners, but we just covered all of it. I have more detailed lessons on this topic, but for now let's just move on. I can increase the size of fire particles here on line 40. I can also give them some horizontal wobble using the same technique we used for flying enemies. For each frame I increase x by a sine value of ever increasing angle, and it will map horizontal x positions along an endless sine wave shape. If you are a beginner, all you have to understand about this is that if you pass math.sine an ever increasing angle value, our angle is increasing here on line 50, it will map positions along a wavy path. If you look at the particles now, there is some left-right wavy movement. I can also make the particles shrink slower by adjusting this value. This will result in a longer fire trail as particles take longer to be small enough to be removed. I can make the rotation faster or slower by adjusting this range of values. I can increase particle size. I can make them shrink faster. In main.js I remove this console log on line 53. I want to make sure we don't get too many particles. I want to have a property that will limit the maximum amount of particles we allow in our game, so we can easily adjust that value if we need to. So inside update method on the main game class, in this section where we handle particles, I say if the length of particles array is more than 50, I want to slice the array and remove everything from 50 upwards. I do that by taking this.particles and assigning it to the same array but sliced from index 0 to index 50. It will only allow the first 50 particles to be in this array. Anything over and it will get sliced away. Slice method returns a copy of an array with only a portion of elements from start index to end index we defined. The original array will not be modified, so that's why I'm overriding it like this, because in this case I want to modify the original array. So we have some hard-coded values repeated here and here. Let's replace them with a variable. I call it, for example, this.maxParticles. I declare it up here and I set it to 50. I can see it works because it slices particles from the array. You see how they disappear and we are getting gaps in our particle trail. I actually want to slice particles from the other side of the array. I want to remove the old ones, not the new ones. I can change the arguments I pass to slice method, or I can change how we push our dust and fire particles into particles array. In player states.js on line 104, instead of using push method, which adds one more element to the end of the array, I will use unshift built-in array method instead. Unshift method adds one element to the beginning of an array. So now when I'm slicing from index 0 to index 50, I keep those new particles and I'm removing old ones if their index exceeds the value stored in maxParticles variable. I do the same thing on line 48. I will be unshifting dust particles, adding them to the beginning of our particles array. To check if everything works, I will console log this.particles from here. It starts empty. If we start rolling, it fills with fire particles. If we run, it fills with dust particles. It never exceeds 50 particle objects, so our slice method is correctly limiting the length of the array. Nice!
I'm on a strong computer, so I will set my maximum particle limit to 200, but you can keep it on a lower number if you want to, it's up to you. I will also delete this console log on line 57 to clean up. Congratulations on completing this lesson. In the next part, we will make our game look and feel better by adding more animation. It will help the player to get more visual feedback to the events happening in the game. I'll see you there. Hey creative coders, in this episode we will finalize player abilities and particle effects. We will animate collisions with a special sprite sheet, and we will add win and lose condition based on game timer. We will also clean up some loose ends in our code. Let's finish the base game and then we can talk about some optional bonus features. Have fun! I want to create a second attack. This time it will be a crushing meteor attack from above. Player can only enter this state when it's in the air. It's a perfect use case for state design pattern we have here in our code base. When the player is running on the ground and we press down arrow key, it sits down. When the player is up in the air, we press down arrow key, it will do a crushing dive attack from above. I copied the entire code block with the rolling state class and I call it dive in. I also pass a string that says dive in all caps to superclass constructor. All the values inside enter method will stay the same because dive in uses the same sprite animation row as rolling. We will also leave the same fire particles code because dive in also leaves a fire trail. While the player is in diving state, it is just moving fast towards the ground. When it hits the ground and this statement is true, we switch player to the running state to keep the momentum going. I can delete this entire else if statement. And here I say else if input includes enter and player is on ground, transition directly into rolling state. It should make the transition animation connect better. We have our dive in state, but there is currently no way to enter that state. Let's define rules for when it can happen. We can enter dive in state while we are in a jump in state. When we are jumping and we press arrow down, we set state to dive in and game speed will be 0 because we are moving directly down. Let's take full advantage of the fact that the scrolling speed of our game world is connected to player states. We can also enter dive in state while falling, so I just copied the same else if statement here. And we can also dive while rolling. Let's test it and see. I save my changes and the code breaks because we need to import and instantiate the new dive in class. I import it on line 1 and I create an instance in this.states array on line 21. It works! I want to feel like we are slamming into the ground with a great power, but right now the player hovers in the air for too long. In enter method on diving state class I set velocity y to +15, instantly giving the player a massive push towards the ground. Nice, now it feels like there is some power behind that special move. As I'm diving and hitting the ground, player kinda gets stuck below the ground level. Let's fix that. So here, inside update method on player class, we handle horizontal movement and horizontal boundaries. Here we handle vertical movement, and vertical boundaries will be defined here. Let's keep ourselves organized. I want to make sure that the player cannot get stuck below ground level like this, so I will limit its vertical position. If this.y is more than the height of the game area minus the height of the player minus ground margin, set player's vertical y position to game height minus player height minus ground margin, like this. Now the player can never move to the space below this point, below the level of ground texture in our game world. We have one more particle class I called Splash. When the player does a meteor dive attack from above and it hits the ground, I want it to do a flame explosion and I want the flames to splash in all directions to make that move look and feel very powerful. Constructor will need 3 arguments as usual, game and x and y positions. I trigger constructor on the parent superclass and I pass the game along, so this code will run. Size of the splash particle will be a random number between 10 and 200 pixels. This.x is x, this.y is y. Speed x will be a random number between -3 and +3 because I want them to splash in both directions horizontally. Speed y will be between 2 and 4, for example. I want the particles to start moving up, but as the gravity slowly grows stronger, I want them to curve and start moving down. Similar principle we used for player jump-in logic. Image will be the same one we are using for fire particle class. Update method will at first call update on the parent particle class as usual.
Gravity from line 40 will be slowly increasing by 0.1, and this.y will be increasing by the ever-increasing gravity value to get that curved path. Draw method will just draw the fire image from line 41. We are exporting splash class, so I import it on line 1 in player states.js. I can't really create this particle explosion when we enter dive-in state, because at that point the player is still in the air. I want to create it as we hit the ground, so I could add exit state to all my states, which would be an ideal location for this to happen, given our code structure. I can also create some small transitional state just for this. Or I could just do the simplest option and create the explosion in this else if statement on line 133. When player is in diving state and handle input method detects we touch the ground, we set player state to run in and we create our splash particle. I use unshift again to add one particle to the beginning of the array and I pass it game, x and y position of the player. One particle wouldn't be very impressive, so I create a for loop here and I will run it 30 times. We will create a splash of 30 particles. I'm getting some errors. It's here on line 1 in player states.js I misspelled my class name. When I dive I get another error. It just says that I forgot to pass context to draw method on splash class. Console errors are usually good at pointing us to the file and line of code where the problem is. These two errors were easy to find and fixed thanks to my browser console. Now when we hit the ground we get a splash of particles. I offset initial x coordinate, maybe like this. I also offset the y coordinate. I adjust the initial position values I pass to splash particle class constructor. I'm kinda just playing with the values and offsetting them in random way because I want the particles to shrink in size, which makes them move towards their top left corner. I adjust this value. There is a better way to deal with this, but I think for the purposes of this class we can just do this quick hack. It will look good enough. And I adjust speed x like this. This looks alright for now, I think. We get a nice impact animation when we hit the ground. Perfect. I also want to have a player state that will play dizzy animation when we get hit by an enemy while we are not in a fireball state. I call it hit. I delete this line that adds fire particles. I also delete this. I check my sprite sheet and I can see that max frame for this animation is 10. Frame Y is 4 and I delete this. I will spell class name like this and I pass it hit here. With this state class I will do something I haven't showed you before. We can enter a state, have it play its animation row once, and when that animation has been played we automatically transfer to another state. So the trigger for switching state will be animation frame this time. So while we are in this hit state, this animation row is playing. I will wait until frame X is at position 10 and I check if player is on ground and I switch player back to running. Else if we are on the last frame on this animation row and if player is not on the ground, we set state to fallen. Nice! Up here I can see that hit state has an index of 6. I import it into player.js module and I instantiate it as the item with an index of 6 inside this.states array. Ideally, I want to do all my state swapping from within player states.js. I could do it through a set of flags and flipping values around, but since this class is beginner friendly, I will do a simple thing and switch my state from here now. I want to enter this new state when player collides with an enemy and it's currently not in rolling or diving state. So if collision is detected, we will always mark enemy for deletion regardless of what type of collision it is. I delete this else block, we won't be needing it. We are going to run if else statement if collision is detected. If we detect collision and player is currently in rolling or diving state, so index 0, 1, 2, 3, 4 and 5, player is invulnerable in these states, so it will destroy enemy and give us +1 score. This.current state is this.states for rolling, or if this.current state is this.states 5, diving, increase the score. Else, meaning the player collided with an enemy while it wasn't in one of those two states, it means player will get hit by enemy and it will play the hit animation. We will of course get no score points for that. I call this.setState and I pass it 6, the index of hit state
and I pass it speed 0 because I want the game to stop moving for the duration of this state, to properly emphasize that we collided with something. If I test it, I can see the score is correctly increasing as we hit enemies in rolling or diving state, and if we collide with an enemy while not in one of these states, we enter hit state. Perfect. Great job if you are coding along. Hope you are getting a lot of value. When the player collides with an enemy, I want to run this sprite animation. Let's handle that logic in a separate module. I will call it, for example, collision animation JS. You know how we do this by now. There will be a class called collision animation. Constructor will expect game object reference and x and y positions. We convert game into class property as usual. You can download the image in the video description. I place it in my assets folder and I link it here in index.html. I give it an ID of collision animation. I hide the image with CSS. Sprite width, the width of a single frame is 100 pixels. Sprite height is 90 pixels. We will have size modifier to randomize the sizes a bit. It will be a random value between 0.5 and 1.5. The width will be multiplied by this .modifier value like this. Sprite width times size modifier. Height will be sprite height times size modifier. It's a rectangular image and I want X position to be in the middle of the image. That's why I waited until now to convert X and Y into class properties. We can only do it after we calculate the width and height of the animation. I want to push X and Y over the center of the animation, so X will be X coordinate passed as an argument minus half of the width, Y will be Y coordinate minus half of height. Frame X will start at 0, max frame is 4. Marked for deletion will be false at first. We are animating a sprite sheet, so as usual we use a draw image built-in method and pass it 9 arguments. Image we want to draw, so this.image from line 4. Source X will be frame X times sprite width for horizontal navigation around the sprite sheet. Source Y will be 0 because this sprite sheet has only one row. Source width is sprite width. Source height is sprite height. So these 4 values specify which area we want to crop out from the source sprite sheet. Now I pass it 4 more values. Destination X will be this.x from line 10. Destination Y is this.y. Destination width and height will be the width and height we calculated on lines 8 and 9. These last 4 values determine where to draw that cropped out frame on destination canvas. Update method will make sure that collision animations move with the game world, so this.y minus equals this.game.speed. We export the class up here on line 1. I import it up on line 2 in player.js because this is the module where we handle collisions. I create an array that will hold all currently active collision animation objects. I call it this.collisions and it will be an empty array at first. We have collision animation class available, so I go down to check collision method and every time player collides with an enemy, we set marked for deletion on that enemy to true, and I will also push one new collision animation object into this.collisions array. I can see it expects game, x and y, so I pass it this.game and I pass it x and y coordinates of that enemy. Since enemy is a rectangle, I pass it in the middle of that rectangle horizontally and vertically like this. I want the collision animation to be centered exactly over the enemy that just collided with the player. Inside update method on game class, down here we will handle collision sprites. For each object inside collision array we will call its update method. And I will pass it delta time because we want to slow the animation down. If that collision object is marked for deletion, I splice it out of the array, same as we did with particles. Inside the draw method I will cycle through all the collision objects again and I will trigger draw method on each one. Nice, we are drawing collisions. We are just drawing the first animation frame in the sprite sheet. Let's go here inside draw method on collision animation class and animate frame X. If frame X is more than max frame, set marked for deletion to true. I console log collisions array and I can see that collisions are correctly being added and removed. I can delete this console log. Collision animations are running very fast. We can control their FPS, frames per second, using delta time. Delta time is the difference in milliseconds between the timestamp from this animation frame and the timestamp from the previous frame. It will be passed as an argument up here. We will need three helper properties. FPS will define frames per second. Frame interval will be the amount of milliseconds that need to pass before we serve the next animation frame. It will be 1 second, 1000 milliseconds, divided by FPS. Frame timer will be counting from 0 to frame interval over and over. Every time it reaches the value in our frame interval, it will reset back to 0 and it will serve the next animation frame in our collision animation sprite sheet. So here I say if frame timer is more than frame interval, only then serve the next horizontal frame and reset frame timer back to 0 so that it can count again for the next loop. Else, keep increasing frame timer by delta time. Now collision animations are animating at 15 frames per second. I can also randomize that FPS, not sure what that will look like. Let's try a random number between 15 and 25 frames per second. I can make that a larger number. It will be capped at 60 FPS anyway. I think smaller numbers will look better since this sprite sheet only has 5 frames. This will make sure they don't disappear too fast. I will set the initial value for debug to false so we don't see collision rectangles on the first page load. You can still view them by entering our debug mode by pressing the letter D. Win condition for this game will be a time limit. We need to get as many score points as possible within a specific game time window. I want a fast-paced fun game. We will store game time in this .time variable here on the main game object. When time reaches max time value, the game level is complete. For testing purposes, let's set that time to 2000 milliseconds, 2 seconds, just for now. Inside update method, we will be increasing game time by delta time. That's passed as an argument up here. Milliseconds between animation frames will be accumulating in this .time variable, giving us the total amount of time that has passed since the game started. If time from line 33 is more than max time from line 34, we set game over to true. We need to declare this game over property up here. When the game over is true, I want to display a scoreboard, a custom message, and I want the game to stop animating. Down here in animation loop I say, only request the next animation frame if game over is false. This will make the game freeze and stop animating when game over happens. I could also have just disabled controls and have the player running endlessly in the background. You can customize your game over screen later based on your preferences. I open UI.js and here I want to display game time and game over messages. Let's start with the timer. I want the font to be smaller, let's say 80% of the font size we used to draw score. I call fill text and I say time :space plus this.gameTime at coordinates 2080. Nice, we are drawing game time. We will fix this, but first let's also draw game over message. If game over is true, set text align to left. I want font size to be double of the base value. I will have two messages, one where the level is successfully completed and one for when the player fails to get enough score points in time. This will be the winning message. I will say booyah in large letters. Coordinates will be the middle of canvas. So game width times 0.5 and game height times 0.5. Okay, I set text align to center. I need to fix this to actually set font size correctly. I need to move this space from here to here. And the same on line 14. Nice. Winning message will have a second line of text with smaller font size that says, "What are creatures of the night afraid of? You!" Exclamation mark, exclamation mark. This message will show up when we win. I change font size to 70%. I move the first line up 20 pixels and the second line down 20 pixels. Nice, so this is our winning message. I want this message to display if score is more than 5, for example. This is just for testing purposes. When we have the whole game working, you can tune it and you can set game time and the score required to win the game to different value, depending on how difficult you want your game to be. If game score is more than 5, we display this message. Else, meaning game over is true and game score is less than 5, we display a different message. I will say love at first bite. I like to keep the Halloween theme. The second line will say nope, better luck next time. So this is when we fail the level. To test it, I give us more game time so we can get enough score points. 10 seconds. Nice, win condition works well. And now lose condition, let's wait. Perfect, we can also lose if we don't get enough score points in time. We need to fix game timer, it's showing milliseconds. I want it to show seconds, so I multiply it by 0.001 to move the decimal point from milliseconds to seconds. And I only want to see one decimal space. So built in JavaScript to fixed method and I pass it 1. We can also highlight the text to make sure it doesn't blend in with the background. I wrap all the code inside the draw method on UI class between save and restore. That means all the settings here will only affect this text. I want to apply canvas shadows and I don't want them to be applied to player and enemies. Canvas shadows are still not well optimized in Firefox, so if you notice lower frame rate, I suggest you don't use them. But if you want to know how to use them, it's simple. Shadow offset X 2 pixels, shadow offset Y 2 pixels, shadow color white, and shadow blur 0. Now our text gets a nice white highlight. We could also achieve the same effect by drawing the same text twice, and the second one would have 2 pixel horizontal and 2 pixel vertical offset. That would be more code, but it's more performance efficient than using built-in canvas shadows. Let's clean up the code and fix some small bugs we have here. When the player gets hit, I don't want it to be able to move left and right. When the player is in state 6, left and right arrow inputs will be disabled. On line 11 in collision animation.js, we are calculating vertical y coordinate, so this value should be height. In running state, we are setting max frame to 6. We are missing 2 frames. Max frame should actually be 8. When I'm rolling on the ground and I press down arrow key, player starts diving and it's causing this weird movement pattern. We are not supposed to be able to do a dive attack when we are on the ground. We can only switch to diving state when the player is not on the ground, like this. That fixed it. One last small thing is here on line 61 in main.js, we don't really need to call slice method. We can just set length of particles array to max particles value like this. In the next episode, we will add more bonus features, but from this point you can consider the game complete. Feel free to add your own features and run your own creative coding experiments. I'll see you in the next one.
This is a final episode where we quickly implement some of the bonus features I showed in the previews. We will improve visuals and clean up our code. I will start by quickly changing background images just to keep things interesting. You can download the forest background layers in the video description and I just replaced them in the assets folder, overriding the city images. I backed the old images up somewhere else on my computer. You can also go to background.js and adjust speeds of individual layers. Sometimes different background art looks better when speed modifiers on the background layers are adjusted. I also changed ground margin on line 17 in main.js to better fit this new forest environment. Since we are changing visuals, let's also change the font to something nicer. You can go to Google Fonts and choose any font from there. It will all work and it's very easy to implement. Let me show you with Creepster, because this is a Halloween themed game. We are in a scary dark forest escaping from creatures of the dark. When you choose your font, click Select this style. Now I click up here and it will give us everything we need to use this font on the web, in our web browser game. I copy this link tag. You can also select multiple fonts and they will be automatically added to the same tag. I will use just one font for now. I copy the link tag and I paste it up here in index.html. Notice I put it before my custom style CSS file because I want the font to be available when that file loads. Then I just take this CSS rule and I apply it to canvas element. Now I can use this font all over my project and Canvas will draw it. I will use it in UI.js for score, timer and game over messages by replacing Helvetica with Creepster here. I think this looks much better and you can choose from so many different Google fonts to fit the art style of your game. I have other favorites on here, for example a font called Bangers for a really cool comic book art style. I want the player to have a limited number of lives and I want those lives to be displayed on screen. Each life will be represented by a small image of dog head. You can also use heart image or something completely different, it's up to you. If you want to use the same image as me, you can download it down below. As usual, I bring it into the project here in index.html first.
Then I hide it with CSS. I will be drawing the lives here in UI.js, so in the constructor I bring the image into the project like this. I will call it, for example, this.lives image. Down here under timer we will draw player lives. I will call draw image and I pass it the image I want to draw. I want to draw it at coordinates 20, 95 and width and height will be 25 pixels. Nice, we are drawing it here. I create this.lives property on the main game object. Let's start with 5 lives. Back in UI.js I create a for loop that will run once for each live and it will draw an image that represents it. Now I'm just drawing 5 images on top of each other. I need to multiply horizontal x position times index from the for loop. Actually it will be the width of the image, so 25 pixels, times index plus left margin of 20 pixels. Perfect. Now, when I change the value here, it changes how many lives are drawn on screen. Maybe you want your game to be easy, you can give the player 15 lives to start with. I will go back to 5 lives. In player.js, in the area where we handle collisions, when the player collides with an enemy while not rolling or diving, this animation is played by setting state to state 6. We call that state hit, and at the same time I want to remove one life, so this.game.lives minus minus. After we removed one life, we check if total lives are less or equal to 0, and if they are, we set game over to true. I tested by colliding with enemies on purpose. You can see that each time we collide, we lose one life per enemy, and when we lose the last life, we get game over screen. Perfect. I want score numbers to fly from enemies as we defeat them. This can also be used for other floating messages in our game. I create a new file called floatingmessages.js. I create a custom class I call, for example, floating message, and I export it. Constructor will expect value of the floating text, starting x and y position, and target x and y position. Text with this value will float from this position to this position, and then it will disappear. I convert these values to class properties as usual. I also create a property I call timer, just to set some simple time limit after which the messages disappear. We will need update and draw methods as usual. Update method will push horizontal x position by the difference between target position and the current position, making it slowly move towards the target. Same for the vertical y position, difference between vertical target and current vertical position. For each loop, timer will increase by 1. When timer is more than 100, we set marked for deletion to true. Draw method will take context as an argument. We set font to 20 pixels creepster. Fill style will be white, and fill text will draw value from line 3 at its current x and y coordinates. Now I show you an alternative to using canvas shadows. For score and timer we are using canvas shadow properties. Here we will achieve the same effect by drawing the same text twice, white first, then black on top of it, and we give it 2 pixels horizontal and 2 pixels vertical offset. We are exporting our new floating message class. I import it up here on line 3 in player.js. Inside check collision method, when we successfully hit an enemy and score increases, I want those score points to fly from that enemy towards our scoreboard. I say this.game.floatingMessages push, and I want to use floating message class to create one new floating message object. First, I need to go to main.js, and on the game class I create this floating messages array. It will be an empty array at first. Now I'm pushing a new floating message into it like this. I check here and I can see that class constructor expects text value, starting x and y coordinates, and target x and y coordinates. Value will be +1 because we get one score point. We could also make this value dynamic if every enemy type gives different amount of score points. Starting coordinates will be x and y of the enemy we just collided with, and target x and y will be, for example, the top left corner of canvas, so coordinates 0, 0. Inside update method on game class, the same way we cycle through all enemy object inside enemies array, we will also cycle through all floating message objects inside floating messages array. For each message, we will trigger its update method. I delete this splice to remove old messages because we will do it in a better way. I'll get to it in a minute. So for every floating message object, I call their associated update method. I copy this code block, and inside draw, I also call draw method on every message and I pass it context. If I play the game, messages will be moving too fast, so there is no animation. I just see the bottom of the letters here. I need to go to update method and I need to multiply both of these by 0.03. So I'm saying here, for each animation frame, increase the current vertical and horizontal position by 3% of the difference between the target position and the current position. This will make the text move towards its target position by 3% of the distance per animation frame, meaning it will start moving fast, and as the distance between current and target position gets shorter, so it's a smaller number, 3% of that value is less pixels, so it will travel slower and slower, giving us a nice ease out effect. You can see that the movement is faster at first, and it slows down as the letters float closer to target 00 coordinates on canvas. I adjust the target coordinates. I want them to flow somewhere to the end of score line, maybe these coordinates. Yeah, let's do 150 and 50. Right now, we are creating an ever-increasing floating messages array because we are not removing the old ones. I will use filter array method to do that. It's better than using splice for a reason I will explain in a minute. Built-in array filter method runs a provided callback function once per each element in the array. Array elements which do not pass the callback function test are skipped and are not included in the new array. So when I say this.floatingMessages.filter, and as a callback I say marked for deletion property on each object needs to be false. The new array will contain only elements that have marked for deletion set to false. Elements that are set to true will be excluded. At the same time, I am assigning this new filtered array to the original floating messages array, overriding it. So this simple line of code filters out all elements that have marked for deletion set to true. In the previous episode, I mentioned a bug where I noticed that ground enemies jump and wiggle horizontally even when they are supposed to be static. It's especially visible when comparing ground enemies against the ground texture, but it is actually happening with all enemies. It is because as I cycle through the array, I am removing enemies that collided with player or moved off screen using splice. Problem is that when I splice out and remove enemy from the array while I'm in the middle of cycling through that array, it changes index of all the following elements, in our case enemy objects. Because of that, their position is not calculated correctly for that loop and they jump around. Instead of splice, I will use filter method and I will only remove enemies that have marked for deletion property set to true after we finished cycling through the entire array, so there are no problems with indexes and skipping positions. Basically, I will do the same thing for enemies I just did for floating messages. I will also do the same thing for particles like this. And finally, I also do it for collision animation objects. Now that's better, we fixed the bug and I think this syntax is a bit cleaner as well. I just quickly console log all my object arrays. I put it inside add_enemy so it logs it only periodically, not for every animation frame. I play the game and I can see that all the arrays are being correctly filled with objects and those objects are also being removed. Perfect. Player class doesn't have this.currentState property because I had to define it from inside game object here. That property belongs on player class, so I can define it here and initially I set it to null. This is just a cleanup, the code will still work the same. Let's tune the game difficulty to make it a bit more challenging. Max time will be 30,000 milliseconds or 30 seconds. In this time, the player needs to reach at least the minimum winning score of 40 to see the winning message. We can do other things. For example, every time player gets hit by an enemy and this animation is played, we can remove 5 points from the score as a penalty. You can tune your game however you want. You can make it easier or more difficult by adjusting these values. When the game is over after 30 seconds, I check if score is more than winning score, and if it is, we display winning message. Else, we display the losing message. Let's test it. I play it and I get hit over and over. My score is in minus values. I get game over and losing message from line 35 is displayed. Nice. I increase game width to 900 pixels. I will keep game height at 500 pixels because our background images are optimized for that size. We're not gonna go into aspect ratio calculation in this class. This time I will really try to play the game and let's see if our winning condition works. I need score over 40 in 30 seconds. It's actually pretty close. Yes, I played well. I got 55 score points and winning message is displayed. Awesome. We are done. Let me know in the comments if you coded all the way through and if you learned something new. I'll see you later.